Thank you very much, Fezani, and welcome and good morning, everybody. Good morning, all participants, to this very important conference, which is a follow-up to a series of conferences that have taken place thus far, trying to promote and build an understanding and appreciation of our groundwater situation in the SADC region. I will be your facilitator just for this opening session, and my name is Perara Muedi. I am currently the Executive Secretary of the Okavango River Basin Water Commission, based in Gaborone, Botswana. And my involvement in groundwater stems from a very long time, and therefore groundwater is one of the subjects that I'm very passionate about. Not only because it's an interesting subject, but because of its importance as a source of water for our region. I will be taking you through the process and introducing our respective panelists or delegates that are going to be giving you opening remarks. But maybe before I go there, I would like to say a few words in terms of groundwater and its relevance to the region. You may or may not be aware that groundwater development at the regional scale in this region in SADC started already in 1998, when we were already developing at the time the Regional Strategic Action Plan, RSAP, that we all commonly know. We were able at that time to develop a groundwater management program, which became an integral part of the RSAP-1 as project number 16. And then therefore, groundwater has always been a very important component of the water sector development in the region. And issues around groundwater promotion were already included in that first groundwater management program. The current institution, the SADC-GMI, was already envisaged as one of the activities that were proposed in that program, and therefore the effort that has gone into establishing SADC-GMI and now currently being able to carry out these conferences, it owes its origins from those who were there before us, starting the process of groundwater awareness and groundwater development in the region. Our topic of this particular forum is very fitting, as it addresses very pertinent issues of enhancing groundwater management, or rather enhancing water and food security through sustainable groundwater development in the SADC region. Sustainability being the order of day. As we are all aware, groundwater is the only reliable resource to about 70% of our people, especially and in particular when you are having issues of water scarcity, such as in drought situation, because of its unique nature of being underground. Albeit this peculiar dependence on groundwater, it's still one of the resources that has been least developed, and that requires to be addressed very well in terms of all development criteria that are required to develop a water resource. Having said this, I would like to therefore start calling on our Executive Director, Dr. James Sauramba, who is going to be giving a welcoming remarks to the participants. And he's been the head of the Groundwater Management Institute for quite some time, and he will be giving us the open remarks. Dr. Sauramba, you have the floor.
Thank you, Tatepera, for introducing me. And thank you for the opening remarks. Let me start my prepared speech to welcome participants to this third SADC Groundwater Conference under the theme as highlighted by our session chair. Program Director, Tatepera, representative from the Republic of Mozambique, the current chair of SADC, the Republic of South Africa representative, where we are hosted, representatives from the member states, Dr. Kabea from the SADC Secretariat, who is also the chairperson of the SADC-GMI Board of Directors, members of the Board of Directors, whom I have seen on the platform today, heads of government ministries, departments, and agencies from across the SADC region, representatives of universities and research institutions that we work with, development partners represented today, private sector representatives, non-governmental organization representatives, members of the technical committee that facilitated the technical quality of this conference, members of the organizing committee who made this specific gathering possible, SADC-GMI staff who worked tirelessly for this event today, members of the media in the house, ladies and gentlemen, all protocol is observed. Let me start by greeting you all in the four key languages or formal languages in SADC. Good morning, bonjour, bon dia, habari za asubuhi. It is my pleasure to be a part of this special gathering to deliver special opening remarks on behalf of SADC-GMI, its stakeholders, board of directors, staff, and on my own behalf. As we continue to curve our stature as a center of excellence for groundwater management in the SADC region, this is our third consecutive SADC Groundwater Conference, whose themes revolve around enhancing partnerships with the scientific fraternity to answer the intriguing question of groundwater for what. This endeavor took us through a series of conference themes in the last 2 years. In 2018, the theme of the conference was adapting to climate change in the SADC region through water security, a focus on groundwater. Last year, we convened from the 4th to the 6th of September in Johannesburg to host the second groundwater conference under the theme Groundwater's Contribution to Achievement of the Sustainable Development Goals in SADC region. In that conference of last year, there were 3 sub-themes. The first one was contribution of research towards the understanding the status, trends, and risks to groundwater. The second one was measuring progress towards attaining Sustainable Development Goals targets, data collection and management within the SADC member states. And the third sub-theme was on policy, legal, and institutional considerations at the national and transboundary levels. In the last conference, we had 48 oral presentations, and we also had 9 posters that were made over the 2.5 days of the conference. Out of the 136 people that had expressed an interest to come to the conference last year, about 125 attended, which was almost 90% show-up rate. Participants from the member states came from 13 of the 16 SADC member states, with the largest contingents coming from the Republic of South Africa, of course, due to proximity. However, we didn't have participants from DRC, Madagascar, and the United Republic of Tanzania. Other participants also came from across the world, including from Nigeria, the Netherlands, France, Germany, Ghana, USA, but to name but a few. Amongst the participants, we had 12 young scientists, 5 females, and 7 males, which is about 10% of the participants that were at the conference last year. This demonstrated the urgent need, which was also one of the conclusions in the conference, that we should urge the young professionals and the youth to participate in this conference. And this culminated in our decision this year to allow the young professionals and students to participate free of charge. 4 key messages came out from the presentations in last year's conference, and I'll highlight these 4. One of them was talked about the importance of groundwater in coping with water security and the challenges brought about by climate change. There is a need to develop regional groundwater assessment and exploration strategies. We should not leave anyone behind as we work towards achieving the SDGs, we should endeavor to couple citizen science with research discourse. The third area that came out of the last conference was that the fourth industrial revolution is here. Let us therefore apply innovation, research and development, and evidence-based approaches, use the technology and novel techniques in this age to advance our agenda. And finally, although none of the SDGs mentioned groundwater explicitly, 53 of the 169 targets have clear links to groundwater, particularly those pertaining to SDG 6, 12, and 13 that signify the importance of groundwater for achieving these goals. This is therefore an opportunity to impact other interrelated sectors. Ladies and gentlemen, I'm proud to acknowledge that over the past 12 months, SADC-GMI and our partners have instituted measures and processes to address some of the key outcomes from the last conference to a varying degree of success. This thought process guided us to explore how we can enhance more action in sustainably utilizing groundwater resources to enhance both water and food security in the SADC region. Therefore, this third virtual conference that we have gathered to participate in today is under the theme Enhancing Water and Food Security through Sustainable Groundwater Development in the SADC region. The primary objective is to advocate for more central and pronounced role for groundwater in the WEFE nexus dialogue to build resilience through minimizing shocks, risks, and vulnerability to climate change. Water, energy, food, and ecosystems are interlinked, and hence they require joint planning in order to meet the daunting regional challenges related to water, energy, and food security, and maintaining ecosystems' health, and subsequently reaching the SDGs. Enhancing the contribution of groundwater within the framework of water, energy, and food nexus requires the understanding of hydrogeological systems, elevating the role of information systems in managing groundwater, and strengthening groundwater governance frameworks at both national and transboundary levels. We are excited about the high caliber of keynote speakers and presenters who have come forward to join us in this conference to scientifically tackle the critical issues that need to be operationalized and to offer robust scientific solutions that will enable groundwater to play a central role in enhancing water and food security in the SADC region. In conclusion, let me extend my sincere appreciation to members of the organizing committee and the technical committee who worked tirelessly to make this conference possible. Special mention also goes to the following institutions that contributed financially to make this conference possible: the International Union for Conservation of Nature, International Water Management Institute, United Nations Educational, Scientific, and Cultural Organization, University of Strathclyde, JEF and SIWA through the World Bank. And finally, let me once more sincerely thank you all and I appreciate you for taking the time to come and join us in this conference and to make it possible for us to maintain the routine, to meet annually and discuss the very important issues of groundwater, which is a conjunctive resource that we have to highly prioritize for sustainability and resilience in the SADC region. I thank you.
Thank you very much, Dade James. This was a very good startup for us to appreciate where we come from with the groundwater process, particularly the conference series. You have highlighted very important elements of why groundwater is important and why it is relevant for us in this particular region. I hope colleagues would have listened and understood that this is a very high priority subject that we want to proceed with going forward in the future. Thank you very much again for mentioning the past conferences and what they achieved, so that we are very much aware of what our role is in this particular one and the set expected outcomes that hopefully by the end of the conference we'll have very clear recommendations that can go into building groundwater in the region. I would like to take this opportunity also to recognize our dignitaries here, the chairperson of SADC Water Resource Technical Committee, Dr. Masias, who is going to be making the speech to welcome the participants. But before we come to that, I also want to welcome the SADC Secretariat representative, Dr. Patrice Kabea, who is in charge of water coordination within the SADC region, and would want, as representative of SADC, to give him an opportunity also to say a few opening remarks on behalf of the SADC Secretariat. Dr. Kabea, you have the floor.
Yeah, thank you very much, Tatepera, and for facilitating this very important conference. And the program directors, executive director of SADC-GMI, representative of the Republic of Mozambique, the current chair of SADC, representative of the Republic of South Africa, SADC-GMI host, representative from the SADC member states, member of the SADC-GMI board of directors, head of government ministry, department, and agency from across the SADC region, representative from universities and research institutions present here, representative from our development partners, private sector representative, representative of non-governmental organizations, member of the technical committee, members of the organizing committee who made this event possible, member of the media and publishing houses. Ladies and gentlemen, all protocol observed. I'm honored to deliver these opening remarks on behalf of the SADC Secretariat and in my capacity as the chairperson of the SADC-GMI Board of Directors. SADC-GMI is our subsidiary institution charged with the implementation of the Regional Groundwater Program as the Center of Excellence for Groundwater Development and Management. It draws its mandate from the regional level policy and the strategic instrument, which include the Protocol on Shared Water Courses and the Regional Strategic Action Plans. We have witnessed SADC-GMI growth and maturity since commencing its full-fledged operation in September 2016, and recorded the phenomenal achievement in asserting itself in leading capacity building and knowledge initiative, as well as becoming the prime repository for groundwater-related data and information. We have also seen SADC-GMI ably embracing its role as the convener of anything groundwater in the SADC region, which culminates in the annual routine to host the SADC Groundwater Conference since 2018, attended annually by a strategy of almost 130 groundwater practitioners, researchers, and experts from across the SADC region, the African continent, and beyond. I fully acknowledge that organizing such conference aligns very well with SADC-GMI strategy to enhance its capacity in addressing the regional groundwater challenges through leveraging on a wider range of willing partners, which include governments, RBOs, regional river basin organizations, ICPs, researchers, universities, and many other institutions in the region and globally. Your participation in this conference is a testimony to these assertions, and I therefore sincerely appreciate your support. In recognition of the importance of groundwater in supporting this virtual-fed SADC Groundwater Conference theme of enhancing water and food security through sustainable groundwater development in the SADC region. The Secretariat and SADC-GMI are at an advanced stage in formulating the sustainable groundwater management in SADC member states. Phase 2 5-year project to be implemented from the second half of 2021 with funding from the Cooperations in International Waters in Africa, SIWA, Trust Fund. The overall objective of the upcoming project is to support sustainable management of groundwater at national and transboundary level to build the resilience across SADC member states. I'm confident that the implementation of the outcome of this conference will be easily accommodated within SADC-GMI features way. In partnership with yourself, I'm therefore encouraging you all to freely deliberate on the issues at hand and make recommendations that will be implemented to enhance water and food security across the SADC region. With these few remarks, let me take this opportunity to once more appreciate everyone for taking the time to join us for this well-subscribed conference. I wish you fruitful deliberations. I thank you.
Thank you very much, Dr. Kabeya, for the opening remarks, which were also very informative to us to understand how this particular exercise is fitting within the bigger scheme of SADC water sector program. And I hope we'll be able to take these points home as we develop our processes continuing going forward. At this point in time, I would like to call our chairperson from the Republic of Mozambique to give his opening remarks to this very important conference. You are on the floor, sir. Hello?
Chair, can I say something, Chair?
Yes, please.
I spoke to Mozambique a few minutes ago, and the director had just arrived in the office. He was trying to log in onto the platform. So I've been checking the participant here. I don't see his name. My assumption, maybe he's still trying to log in. Maybe he's going to be ready a bit later.
Could we then agree with this new information, and in order not to waste much time, to go to the next speaker and allow the chairperson, once he's ready and around, to make his opening remarks? I hope that is agreeable to the Secretariat.
Yes, I think that's best. I think let's take the next speaker. Thank you.
Yes, I think it's best that we do that. The next speaker is our keynote speaker, Dr. Kevin Peterson, who, as all of us may know, he's not new in the groundwater field, and he's been involved in a lot of programs within the SADC framework, including the development of a hydrogeological map of SADC, on which we work together with him, and other groundwater related activities. Dr. Peterson is going to be giving us his insights into the groundwater in the region. And therefore, I would like to not waste too much of our time, hoping that people have read his resume in the conference package. Dr. Peterson, you have the floor to give your keynote address, and then we will revert back to the chairperson once he joins.
Thank you for this. Thank you for this opportunity. Can you see my screen?
Yes, sir, we can see your screen.
Yes.
Very well.
Good. Thank you once again, and good morning. Thank you for inviting me to do this presentation. I appreciate this opportunity and honor bestowed on me to present this keynote presentation at the 3rd SADC-GMI conference. I trust all are well in these unusual times, and that normality will return where we can meet as colleagues around the table, but also in the field. I've been asked to reflect on the unfolding role of groundwater in the water, energy, food, ecosystem nexus. The nexus approach has been put forward as a novel framework to systematically evaluate connectivity and trade-offs between water, energy, food, and ecosystem, based on the premises that managing these resources cooperatively avoids the negative results of more siloed approach for management and policy. However, in assessing and evaluating the connectivity and potential trade-offs in relation to groundwater, the nexus, the question is whether it's a matter of the same wine in a new bottle. We know that growing populations and economies would lead to increasing demand for basic resources such as water, food, and energy in coming years. The consensus is that meeting this demand for the aforementioned resources are at risk due to potential effects of climate change and water governance failures. Nevertheless, water demand is expected to increase to almost 290% by 2030, food demand by 60%, electricity demand by 70%. The figure on the left shows water, energy, and food interlinkages. The most used example is the South Asia example, where groundwater irrigation has been a major driver behind the green revolution, providing food and income to large parts of the population in the region. Groundwater withdrawals have increased more than 100-fold between 1950, which has made India the largest groundwater user in the world. Pumping for irrigation is very energy intensive. About 20% of India's electricity use is for irrigation, and in fact, more than half of India's hydropower production is going into pumping groundwater. The groundwater exploitation was possible due to energy subsidies for cheap energy. Appreciation of this water, food, and energy interlinkages, and the appreciation of social, environmental, and economic consequences could perhaps have informed better policy choices. The 2030 Agenda for Sustainable Development, adopted by the United Nations General Assembly in 2015, includes 17 Sustainable Development Goals, or SDGs, and 169 targets, each of which is designed to stimulate concrete action over a 15-year period. The SDGs are particularly relevant for the nexus, the figure on the right. The water and sanitation goal, SDG 6, which includes sustainable water management and improving transboundary cooperation beyond rivers. The goal to end hunger, SDG 2, which includes achieving food security and the promotion of sustainable agriculture. The goal to deliver affordable and clean energy, SDG 7, which includes providing access to sustainable energy for all. The goal to preserve life on land, SDG 15, which includes the protection, restoration, and sustainable management of ecosystems. And then, of course, the issue of climate action, SDG 13, is also highlighted and has its obvious implications for water, energy, and food. There are many interlinkages between the different SDGs. For example, if you look on the figure, interlinkage 1 between SDG 7 and SDG 2 talks about, for example, agricultural projects and using their waste, which can serve as sustainable energy sources. Another example, interlinkage 5, increased water supply and sanitation infrastructure development requires pumping and treatment, as previously said.
Dr. Peterson?
Yes.
Okay, sorry. I was seeing that there was a swap between the languages, but I think it's now been corrected.
Okay, so
English was coming in Portuguese and Portuguese in English.
Okay, so
it's sorted out.
Okay,
let's
good.
Proceed.
Okay.
Yeah. Good. We can proceed.
Thank you. So the following opportunities for improving the water, energy, and food securities through the nexus approach has been identified by the promoters. This include increased resource productivity, using waste as a resource in multi-use systems, stimulating development through economic incentives and reducing perverse subsidies, governance institutions and policy coherence, benefiting from productive ecosystems, integrated poverty alleviation and green growth, capacity building and awareness building. There has been criticism about the nexus approach, that it's the same wine in new bottle. Some has argued that it's like IWRM and previous attempts to integrate food, energy, and water systems. Some of the issues related to implementing the nexus approach is that food, water, and energy policy and institutions exist in silos and sometimes resist integration. The politics of knowledge in framing global scarcity results in framing of scarcity as one of economics and technology rather than inequality of access. Lack of consideration of the limits of optimization. The food, water, energy nexus is not an equilibrium system, so resource allocation cannot be easily quantified and balanced. Two important differences emerge. The issue of scale, moving from a focus on the river basin level to multiple scales, and also in relation to resource use with the noticeable loss of focus on equitable allocations under the nexus approach. It has been said that the IWRM and current nexus thinking is insufficiently political and may result in the masking of the political constructions of the narrative of water scarcity, efficiency, and rational decision-making. The International Association of Hydrogeologists has brought out a useful strategic overview series addressing the issue of energy generation and groundwater. The generation, consumption, and management of energy interacts with the groundwater domain in various ways. Inputs from hydrogeological science are needed to understand these linkages and for risk assessment and effective management of the interaction. The use of geothermal energy requires hydrogeological science knowledge and also for nuclear power siting and radioactive waste disposal. One of the primary issues related to the exploitation of fossil fuels is aquifer pollution with formation of brines, hydrocarbon compounds, hydraulic fracturing fluids, and stray gas contamination. Injection into gas and oil wells is important for hydrocarbon waste management, but knowledge of the intermediate zone between aquifers exploited for groundwater supply and deeper hydrocarbon producing strata is generally inadequate. Globally, as previously said, groundwater pumping, notably for irrigated agriculture, is a major energy consumer, and much more effort needs to be put into reducing inefficient use due to aquifer depletion and inappropriate boreal design. The extensive cultivation of crops destined for biofuel production widely implies large application of fertilizers and pesticides, and sometimes requires significant irrigation and process. Sorry, I'm just...
Yeah. Okay. Are you okay, Chair?
Yeah, sorry.
Can proceed. Yeah.
Yeah. So the advent...
Good morning.
The advent...
Good morning.
Sorry.
Good morning, Messias speaking.
Dr. Messias, welcome. How are you?
Fine, fine, and you? Sorry for coming late.
Yes, we are in the course of getting the keynote address, and welcome.
Okay.
We'll see you next. It's good
Okay.
you're able to. Thank you.
Thank you. Thank you. Thank you.
Cheers. Dr. Peterson, you can proceed, please.
Thank you. So the advent of unconventional extraction technologies has triggered intensive research interest that spans spectrum of water management issues, public health, ecosystem service, and also induced seismicity. Unconventional energy resources include shale gas, coal bed methane, and underground coal gasification. We have provided a prospective analysis of hydrogeological risk pathways and vulnerability attributes in advance of anticipated shale gas operations in the Karoo Basin of South Africa. The hazard pathway receptors approach was applied to define the hydrogeological system in the context of potential sources of water resource contamination. This case study focused on two critical hydrogeological risk pathways, regional groundwater flow and discrete structural features. Depending on the target area, the capacity of deep natural pathways to enable hydraulic fracturing fluids, chemicals, or produced water to reach shallow groundwater will be reduced or difficult. However, deep artesian water could, however, be intercepted at different depths, and based on past groundwater exploration in the Karoo, water could flow into horizontal fractures or openings characterizing the shallow aquifers, sill ring complexes, lithological contexts, and transgressive fractures across dolerite dikes. However, above groundwater and wastewater management safeguards are needed to protect shallow groundwater from potential water quality degradation. In this example, we describe a systematic approach to evaluate hydrogeological risk pathways and informing adaptive management policies to protect groundwater resources. So we are highlighting here the interrelationship between groundwater and energy development. Recent news reports reveal plans by oil and gas companies to explore for oil and gas in the Namibian headwaters of the Okavango Delta and also at World Heritage sites. Plans are afoot to explore inside the Okavango-Zambezi Transfrontier Conservation Area by opening a new deep sedimentary basin, the Okavango Basin, in the Kalahari Desert of northeast Namibia and northwest Botswana. And the understanding is that there is petroleum systems. If this is to go ahead, baseline information are required and the transboundary water implications needs to be understood. Coming to the issue of groundwater and food, there's consensus that major aquifer basins throughout the world, groundwater depletion has taken place. This is not the case in SADC, and there's opportunity for groundwater irrigation development contributing to food security. So it's argued that the real crisis in sub-Saharan Africa and SADC is not groundwater over-abstraction, it's poverty, underdevelopment, and unemployment, the consequences of which include instability, migration, and radicalization, as well as suffering and deprivation. So most countries' current groundwater use remains under 5% of national sustainable yield. This level of use is likely to be a constraint on wider economic development and addressing vulnerabilities to climate change and shocks. So the contention is that policy need to consider groundwater as a catalyst for development. In a paper that Jude Cobbing and Bradley Healer developed sometime last year, they put forward an empirical model to understand the process of groundwater development with the goal to facilitate progress in sub-Saharan Africa. The model is built around three key phases. The trigger phase, where multiple factors combine to reach a tipping point to trigger intensive groundwater utilization. A boom phase, a rapid scaling up of increasingly sophisticated groundwater utilization and associated economic development. A maturation phase where utilization peaks before either plateauing or moderating through either conservation and or remedial measures, which then becomes influential factors, and economic advances continues via innovation and efficiency gain. So if you look at sub-Saharan Africa, we have not gone through this phase. So we have not experienced the groundwater trigger boom maturation phase, which was evident in many other global regions. So they argue that there's potential for groundwater to play a similar type of role. But in saying that, we need to understand that we cannot play a zero-sum game. While we recognize the opportunities for groundwater development, it's still imperative to understand the consequences of our decision and how we can mitigate the potential undesirable results that emanate from our decision making. So we do not want to play the zero-sum game in terms of chronic loading of groundwater levels, which indicate a significant and unreasonable depletion of supply, significant and unreasonable reduction of groundwater storage, the issue of seawater intrusion, significant and unreasonable degraded water quality, including the migration of contaminant plumes that impair water supplies, the issue of land subsidence, and then also depletions of interconnected surface water. And then obviously understanding what the implications are for ecosystems. So it would be useful to understand our groundwater research in this frame and put in place triggers or thresholds to prevent localized groundwater impacts. In the previous slide, I listed the undesirable results, and it would be useful to understand the thresholds of irreversible degradation, focusing on no-gret solutions. So what are the potential trade-offs for groundwater? So previously I've said we do not need to take zero-sum positions as happened in previous examples across the world where aquifer depletion has taken place because of unconstrained groundwater pumping. But having said that, we need to ramp up groundwater development and use in SADC so that it becomes a catalyst for socio-economic development. So policy should be targeted towards reasonable and equitable groundwater use with obligations not to cause significant harm. Differentiated groundwater use, using poorer groundwater quality for mining, industrial, and energy users. The focus on solar and renewable energy sources. And also trying to fully understand that water and its management are essentially local rather than global. And local problems need global support, not global rules. So what are the critical barriers that we need to overcome? The nexus approach, decisions are political, so we need to take that into account. We're working in an environment where we've got limited data and understanding of the dependencies and connections across the WEFE systems. We're working in a plurality of scale, whether spatial, temporal, institutional, jurisdictional. We have to take policy and legislative considerations and understand to what extent this can be built into decision making. And then obviously there's, in most decisions, there's deference to food security rather than groundwater security. This, in my view, is acceptable over the short to medium term, but we need to understand the thresholds in terms within the context of irreversible degradation. So there's opportunity for groundwater to meaningfully contribute to food security in sub-Saharan Africa. This is a policy opportunity for SADC member states. Food security and energy security may trump groundwater security. But I think for the short to medium term, this needs to happen in order to drive economic development. And we need to understand that solutions for the sustainability of the groundwater lie outside the sector. Thank you for this opportunity to do this presentation. Thank you very much.
Thank you very much, Dr. Peterson, and for a very enlightening presentation on the role of groundwater in the WEFE nexus, which you have really highlighted very, very well. And I hope some of the issues you have pointed out will be points of discussions in the various special sessions that have been organized by the organizers of the conference. You have touched on very important aspects of groundwater research, groundwater used in irrigation, demonstrated contributions of groundwater to the WEF that clearly will help us in enhancing this resource and enhancing food security in the region. I think since it looks like we have some time, I would also like to then call upon our chairperson, if he's ready, to make his opening remarks on behalf of the water sector. Chairperson, Director Macias, you have the floor to make your opening remarks. We had to move to the next presenter, the keynote address, hoping that you have also had a bit of his presentation and you can therefore take on and present your opening remarks to the conference. Thank you, Chair, and you have the floor.
Obrigado. Creio que é o Sr. Pera Ramuel. Bom dia, obrigado a todos. Peço desculpas pelo atraso. A tecnologia às vezes nos trai nos momentos como este. Eu vou fazer algumas notas introdutórias. Foi pedido a Moçambique, na qualidade de atual presidente da SADC, para fazer essas notas. Senhores representantes dos Estados-membros da SADC, senhores representantes dos parceiros de cooperação, senhores representantes das organizações de bacias hidrográficas, senhores representantes das instituições de investigação, representantes das agências implementadoras, eis-me senhor diretor executivo da SADC-GMI, Groundwater Management Institute, distintos convidados, como se diz um pouco aqui na minha terra, todo o protocolo observado. Minhas senhoras e meus senhores, primeiro queríamos, em nome do governo, em nome do nosso Ministério de Obras Públicas, Habitação e Recursos Hídricos e em nome da Direção Nacional de Gestão de Recursos Hídricos, saudar a todos os presentes, desejar boas-vindas. O encontro é virtual, mas queremos desejar boas-vindas a esta terceira conferência de água subterrânea que decorre sobre o lema melhorar a segurança da água e alimentar através do desenvolvimento sustentável da água subterrânea na região da SADC. Esta conferência acontece numa altura em que a região, o mundo, estamos a ser assolados pela pandemia do Covid-19. Isto remete-nos a uma reflexão conjunta sobre o que é que nós devemos fazer para vencer a pandemia, mas também vencer os impactos que esta pandemia traz. Como é que nós podemos nos inserir nas estratégias? Como é que podemos inserir este efeito da pandemia nas estratégias que estamos a desenvolver, sabendo que estamos a viver um novo normal que esta pandemia nos sujeita. Temos também o desafio do alcance das metas de desenvolvimento sustentável, duas componentes, água, também a segurança alimentar. Isto, da nossa perspectiva, só será possível se todos nós unirmos os esforços na planificação, na mobilização de financiamentos, na implementação, na monitoria e na avaliação dos vários planos e programas que a SADC vem desenvolvendo, mas também nos que nós nos propomos a desenvolver e que acreditamos que esta conferência vai ser um elemento catalisador e vai alimentar todo. Todos nós sabemos que na nossa região da SADC, perto de 70% da população abastece de água subterrânea. Estamos a falar de perto de 250 milhões de pessoas que têm como principal fonte a água subterrânea. Portanto, para eles satisfazerem as suas necessidades diárias, dependem só da água subterrânea. No entanto, também sabemos que a disponibilidade dessa água é reduzida. Temos os problemas de qualidade, temos água salobre, temos problemas de poluição provocado pelo excesso de insumos agrícolas, fertilizantes e outros que acabam contaminando os aquíferos. Temos a problemática dos assentamentos desordenados. Depois também temos as questões ambientais, a variabilidade ambiental que traduz períodos de seca mais longos, e isso tem tido impacto na água subterrânea, quer do ponto de vista da sua disponibilidade, mas também do ponto de vista que em períodos secos, em que não temos água superficial, a procura da água subterrânea aumenta. O nosso histórico, grande primazia, foi dada sempre à água superficial e tem-se olhado muito pouco para a água subterrânea. Esperamos que este exercício que hoje estamos a iniciar nesta conferência nos possa ajudar também a aumentar a nossa concentração na água subterrânea, procurando encontrar soluções que sejam mais resilientes do ponto de vista de exploração e desenvolvimento de recursos da água subterrânea. É notório que existe uma falta de informação sobre a água subterrânea e essa falta está a conduzir-nos a uma limitada busca de soluções, uma limitada capacidade de aproveitar todo o potencial que existe da água subterrânea. Queríamos também fazer a reflexão que nem sempre os problemas de segurança da água são causados por falta de infraestruturas. Queremos também aqui desafiar a nossa região a olhar para estudos pilotos que podem trazer-nos um bom passo de progresso no melhor conhecimento das águas subterrâneas. O apelo é que também olhemos para a água subterrânea como uma solução que deve ser otimizada, que deve ser combinada com outras soluções para podermos colocar a nossa região do lado da segurança da água, do ponto de vista particular da água subterrânea. A nossa esperança é que essa terceira conferência traga soluções que nos vão permitir melhorar a segurança da água na região, impulsionar o abastecimento da água, impulsionar a agricultura, impulsionar a segurança alimentar. Queremos chamar a atenção que este impulso só poderá ser conseguido se houver garantias de financiamento para podermos aprofundar o conhecimento que nós temos sobre o potencial hidrogeológico da região. Estamos a dizer que a investigação do potencial, a investigação sobre a produtividade dos aquíferos, quer os aquíferos nacionais como os transfronteiriços, é um elemento importante que a região deve tomar em conta se de fato queremos usar a água subterrânea como um veículo que também vai nos conduzir para o desenvolvimento sustentável do ponto de vista da disponibilidade de água para o abastecimento de água, mas também para a segurança alimentar. Portanto, queríamos, em nome de Moçambique, em nome da Direção Nacional de Gestão de Recursos Hídricos, em meu nome pessoal, congratular os organizadores da conferência, congratular a SADC-GMI em particular pelo esforço que tem empreendido para alavancar a área de recursos hídricos subterrâneos. Desejar a todos uma ótima reunião, que este encontro produza os resultados que nos vão levar a ações concretas para alcançarmos a segurança da água, a segurança alimentar, promovendo o desenvolvimento sustentável da água subterrânea. Moçambique vai fazer tudo para dar continuidade aos trabalhos que têm sido desenvolvidos na região no âmbito dos recursos hídricos subterrâneos. A todos, muito obrigado pela atenção dispensada e uma boa conferência. Obrigado.
Thank you very much, Chairperson, Director. You have actually set a very good framework for us to start discussing this particular subject in this conference. And I take it as a leader in the water sector, we have listened very well for the particular issues that you have put across. I would like to take this opportunity to thank all our speakers in this session, which, as you are aware, is a very unique session where there will be no questions asked, but you take the messages, I hope, as you proceed during the course of this conference and try to understand where we are or where you want to go as groundwater and water sector in the region. I want to thank our chairperson, SADC Secretariat, our presenters as they have been listed, for making this possible, SADC-GMI, the Secretariat, for making this possible for us and facilitating this very important conference. I hope from here we will be able to interact actively in the various sessions as we proceed with the course of the conference. And this is my last session, and I wish everybody very good deliberations as we proceed. And let's participate actively and make sure that we contribute to this very important and noble goal of enhancing water and food security in the region through groundwater management, and I underline sustainable groundwater management, which is very critical. A resource, as we say, is appearing or occurring in relative abundance, even more than surface water, some of which still has a huge potential to be tapped and utilized by our respective countries for their various needs. I will take this opportunity to therefore wish you all the best. We are now at the point where we have to take a coffee break or tea break. In the conventional sense, if we are not being bound by these virtual processes, it will be a time when we could actually take an opportunity to discuss some of the presentations that were given, especially the keynote address, which I found very informative. But as it is, we have 10 minutes of coffee break according to the program, and we'll come back at, if I'm sure, around 9:45. And so we have made very good time. We are almost on time, exactly, it's 9:34. So have a beautiful day and the rest of the conference. And I thank you very much for your kind cooperation in dispensing this responsibility as the facilitator. Thank you very much. I think Secretariat, you can take over from here.
Okay, thank you, Hera, and all the speakers. I think the delegates you have heard. There is one buzzword which is called groundwater, which has been said, Dr. Kevin Peterson, I think he said it more than 25 times, I was counting. So without just taking much of your comfort break, I'm using this opportunity because we managed to save time. I've got 1 minute that I can say some few ways. But anyway, without wasting much time, let's go and have some recess for about 15 minutes. Around 9:45, we'll be back, and then we will start with the theme of the next theme after the comfort break. Let's keep time. So far, we have done so well. Thank you very much. I hope we are all back and ready to proceed with the next session. Next up, we are going to the theme that will be shared. Here on the program, it was saying Dr. Kenabato Pitt, but unfortunately it's not available at this stage. So we're gonna have Brighton Munyai to chair the session, assisted by Dr. Modrak Gomo. However, first, let me just say to the delegates, please be reminded that you need to complete the attendance register and the form for the special session and indicate the language of your preference, so that it can then be easy to be able to allocate interpreters. So without wasting much time, I would like to hand over to Brighton Munyai to take us through the next session. Brighton, thank you. Brighton, you are on mute.
Oh, thank you, Fetsani. Let me take this again. Thank you, colleagues, for coming back, and welcome back to the first session of the sub-theme 1, which is Sustainable Groundwater Use for Food Security in the SADC region. As introduced, I'm Brighton Munyai. I'll be your chair for this session up to 1100 hours. We have a couple of presentations that are lined up. The first presentation has got the title, Doing So Much More, Maximizing Artisan Groundwater for Community-Led Sustainable Agriculture, a case study from the Jordan project of Malawi. And that presentation is going to be done by Muti, if I'm correct, who is with Baseflow. While Muti is loading his slide, I think Muti can load your slide and we can be on the way. Just to remind you that participants, you can post your questions in the chat box, and we'll be happy to facilitate to facilitate the discussion or responses to those questions after the presentations have been done. Thank you. Muti, go ahead.
Thank you very much, Brighton. Are you able to see my screen?
Not yet.
Okay. Says that, oh, okay, fine. Hold on.
Thank you.
Are you able to see my screen now?
Yes, but if you can put it in presentation mode.
Of course. Okay. Thank you very much, Brighton, and welcome everyone to the third SADC-GMI Groundwater Conference. My name is Muti Khema. As mentioned, I'm with Baseflow, and I'll be presenting on the topic of, sorry, let me just minimize this. I'll be presenting on the topic of maximizing artesian groundwater for community-led sustainable agriculture with focus on a project in Jordani. This project was a joint effort between the University of Strathclyde in Scotland, as well as Baseflow in Malawi. Now, before I go into the details of the project, let me just quickly talk about what is an artesian well, in case there are some people who do not know. An artesian well is a type of spring or water well where when a well is drilled into a confined aquifer and the groundwater is under pressure inside that confined aquifer, the water rises through the well and sometimes free flows out above surface, the ground level. Sometimes, of course, you may have an artesian well that does not rise above ground surface. Of course, it all depends on the piezometric level. And one of the special characteristics of an artesian well is that when it rises above ground level, it can sometimes keep flowing and does not require pumping to rise to the surface. Now, looking at artesian wells in Malawi specifically, Malawi has approximately 33 artesian wells across the country. This is based on government records, but we believe this is a gross underestimation. And a number of these artesian wells are free flowing. Now, this is because mostly NGOs or drilling companies that are providing drilling in the country, when they encounter an artesian well, they don't have the knowledge and the technical know-how to actually cap and control it. So they are left free flowing, which is against the Water Resources Act of 2013. And within the act, it acknowledges that the uncontrolled flows could lead to depletion of groundwater, drying up of nearby boreholes, especially if they share the same aquifer, and also declining flow rates across time. Now, in partnership with the University of Strathclyde and a research assistant, her name was Helen Robinson, she conducted a study of hot springs and artesian wells in certain parts of the country. And from that research, we identified a location, a village called Jordani. The artesian well in question is the one you see in the picture. And we secured a 2-year grant from the Scottish Government and co-financing from Irish Aid to trial an exemplar in the village, where we would combine the technical aspects of capping and controlling artesian wells, so the technical aspects of hydrogeology, with community development, which is the social aspect. So that is taking research and putting it into use. So I'll start with the technical aspects of the project. So there were 4 key elements. That is a technical assessment, well remediation, which was the capping and controlling of the artesian well, the wellhead infrastructure design and construction, as well as pressure and flow rate checks. These were the key aspects of the technical assessment, but I'll focus on just a few in detail. Just some information about the artesian well. As mentioned, this is the picture. You can see the condition of the artesian well. They just installed an AfriDev hand pump, and it got corroded to the point that there were holes on the side, and the surrounding was quite unhygienic with mud and breeding of mosquitoes. This, as mentioned, is situated in Jordani village in southern Malawi and was drilled by UNICEF in 2007 and was free flowing since 2007 until 2019. Now, if we were to use the natural yield of the borehole, which is about 0.34 liters per second, we are looking at approximately anything between 130 and 150 million liters of water discharged in that time. So that's a significant amount of water being discharged from that location. But to give you a sense of proportion in terms of how much water that is, if we use the Malawian standard of 40 liters of water per person per day, that's enough to supply a small city like Blantyre, where I stay, of 1 million people for about 3 to 4 days. All of that water just from one location in all that time. Now, looking at some findings of the technical assessment, the technical assessment involved a number of methodologies, water quality tests, pumping tests, as well as borehole camera survey. And key findings were the depth of the borehole was about 51 meters, with which was fully cased with blank casing at about up to about 34 meters. The natural yield, as already mentioned, was about 0.34 liters per second, which is higher than the recommended standard for human consumption through hand pumps. But also, all the water quality tests that were done, field and lab samples that were tested, were within the government standards. And this, of course, we moved on to the remediation after we assessed that the water was potable. And we contracted and supervised a local contractor, Ojimadzi, and this was also an opportunity for them to add a new competency within their offering. We conducted a leakage test using an inflatable packer, and we connected this to a compressor. So basically, we inserted the packer inside the borehole, inside the casing, and we inflated it to build up pressure inside the artesian well. And the reason for this was to see if there would be any leakages and whether the casing and the annulus seal could hold pressure. So after we conducted this, the artesian well passed, and Oh, okay, fine. Okay, fine. Okay, I'll try and slow down. Thank you. So the leakage test revealed that there was a discharge of about 0.3 liters per second and a pressure head of about 2.5 meters or 0.25 bar. So after the technical assessment, which showed that the water was potable and drinkable by the community, as well as the technical assessment demonstrated that it could actually hold pressure, we could move on to the next stages of the project, which was looking at engaging with the community. But before I show that, this is a graph showing the pressure checks. We conducted 27 pressure checks of the artesian well after it was capped to see how it was behaving. You could actually see the artesian well, the pressure will reach a high of about 0.75 bar and stabilizing at about 0.3. Now, this was really important for us to do because it was very important. It was information we're going to use for the design of the irrigation scheme, which I'm going to talk about later on, because we are going to have an elevated tower. So the pressure would tell us how high that tower could be. So this was extremely important for us to see, but also gave us valuable information in terms of how the artesian well behaves across time. Now, moving to the social aspect of the project, these were the key elements. We established a transitional community-based management structure or a project management committee. Now, it was transitional because the committee was meant to only focus on supporting implementation of the community projects, and then it would transition to a management structure to manage the entire system, which I'll show later on. The community also went through a number of trainings. So this was trainings in budgeting, planning, as well as sustainable agriculture. But also we financed the community, the project management committee, with money to implement planned sustainable agriculture activities. And this was done with support from the extension services of the local government. But one thing I think that is very interesting that we integrated within the project was something called developmental evaluation. Now, what this is that normally evaluations are done at the end of a project. For this particular project, we hired a consultant who would independently go into the community to assess whether the project was being socially accepted, owned by the community itself. So it was looking at the social sustainability of the project. And the consultant did it independently, we did not influence him. And the information from that developmental evaluation would then be integrated into the project to ensure course corrections as we moved forward. So these were the aspects of the social engagement with the community. Just some information about the community itself. We did a baseline survey and found that there were 346 households, and each household having an annual income averaging at about $185. One of the things we found very exciting about this community was that they were already showing very strong signs of initiative and ownership before we started the project. They were already using the artesian pressure for fish farming. And we found that they were doing some fish farming on their own. So when we came into the community, we saw the project as not coming in with something new, but enhancing what the community was already doing to extend the productive life or the productive land that was available to them. So it was us complementing them rather than supplanting what they were doing. The established project management committee, as mentioned, the two ladies in the picture here are members of that project management committee, was selected through merit. Now, those of you who have worked in Malawi or some parts of Africa, the chief has considerable power. So instead of asking the chief to pick people to be part of this committee, we chose merit. So we recruited people based on merit, which was not very popular. But we did get the results that we wanted in terms of the projects with some caveats. Now, what has been the socioeconomic impact of the project so far? Now, we say so far because the 2 years of the project ended in September of this year. But as Baseflow, we are continuing to engage with the community through monitoring, mentorships, as well as continue monitoring the pressure at the artesian well. And the reason we are doing this is because we want to ensure that the gains that have been achieved in the 2-year period are sustained across time. So some of the gains that have been achieved include increased productive land, which increased from about 390 square meters to close to 22,000 square meters. And this is because of increasing the capacity of the fish pond that was there, which I'll show you. And also we had another fish pond that was excavated by the community, and another one which was done on their own. So the other one we paid for, but the other one they did on their own. We also installed a 30,000 liter irrigation system with an elevated tank, 3 tanks, 10,000 liter each, which is irrigating land, as well as a new water kiosk, which provided a more hygienic surrounding as compared to the artesian well, which was very muddy, very unhygienic, and breeding mosquitoes. In terms of revenue, the community so far, we estimate, has generated $2,635, but this does not include the irrigation returns, which we are yet to get figures on. But one other benefit that was not planned was that the project managed to reestablish the relationship between the local government, extension service, and the community itself. One of the irrigation farmers, a lady, actually commented to say she had never seen her extension worker, and the project facilitated that connection, which was actually one impact that we didn't expect. These are just pictures of the site, aerial shots. The orange arrow is where the artesian well is, and the red arrow is the fish pond that the community did, and this is before we came in, so this is the before image. This is an after image. You can see where the orange arrow is pointing is the artesian well, now carefully with a wellhead structure, and the red arrows are the locations of the fish pond. Fish pond at the back, as you can see, was drained by the community, and it's often drained and they fill it up again routinely. The blue arrow is the kiosk, and the green arrow is where the foundation of the irrigation scheme is. This is a far recent one. You can see the fish ponds, the tanks for the irrigation scheme, and the kiosk just behind the trees. My last slide is looking at what have we learned from this experience. To share what our lesson is, one of the things I think we learned was that the technical problems on the project, for example, the drop in pressure and other technical problems in terms of the capping, were very tame problems. Not that they were not, it's not that they were not difficult or complex, they were, but the solution to these problems could be defined, and those solutions could be replicated in other places. The social dimension of the project gave us a lot of experience and lessons that we would like to share, because the social problems were wicked. Now, wicked problems are problems that don't have a clear solution definition, and they are connected to other problems within the community, but also because you have multiple stakeholders, all those stakeholders have conflicting interests in that particular project. So we noted that. And our experience from this project showed us that the community is not a blank slate. It is an amalgamation of history, culture, expectations created by other interventionists before us. And the importance of this lesson, though it sounds obvious, is that rather than doing your basic baseline study, you need to understand the community's history with development and their general psychology. The communities are not angels. The $2,635 mentioned is an estimate. The community were not giving us the real information. They were under-reporting, so it could be seen like things were not working out, so they can get more benefits from the project. And this was just one example. If I had time, I have several, where the community was sabotaging the project so that they can get benefits from it. So the communities are not angels. And I want to end my presentation with a question. And the question is this one. And looking at, I was listening to Kevin's presentation, keynote address, and he said, groundwater is a catalyst of socio-economic development. But my question to all of you is this. Is it possible to co-create effective interventions based on groundwater or anything else when the beneficiary community is dysfunctional or the users are irrational? As much as groundwater is a catalyst for socio-economic development, we are assuming that the beneficiaries themselves can take it on and that the beneficiaries themselves are rational. Our experience in Jordan has shown that that is not the case. We are still trying to solve the social problems we encountered, and the problems remain wicked. which is why we have chosen to continue working with the community to find ways of solving those problems. So the question, is it possible to co-create with communities that are dysfunctional or users that are irrational? Our answer right now is we're not sure. We are yet to learn and see if it is possible. On that note, thank you very much for your attention, and that is the end of my presentation. My apologies for being too fast. I hope the translators got what I had to say. Thank you.
Thank you, Muti, for that very informative presentation. Participants and attendees, please put your questions into the chat box. We'll be talking to them at the end of this session before we take another comfort break. Our next presentation, Muti, please stay put. We'll come back to you if there are any questions that are posted in the chat box from the participants. Our next presentation is on the increasing reliance to floods and droughts in the Limpopo River Basin, development of a basin scale hydrogeological model to support sustainable groundwater management. And that presentation will be done by Syed. Syed, you have the floor.
Okay, hello everybody. I am Dr. Syed from University of Aberdeen, and I'm going to present the part of my research work. And the topics of the presentation is development and application of a basin scale hydrological model to increase the resilience to hydrological extremes in the Limpopo River Basin. Limpopo River Basin is highly vulnerable to flood and droughts, and floods and droughts are recurrent events in this Limpopo River Basin. So identification of the appropriate management strategies is important to ensure the groundwater sustainability and to improve the resilience to hydrological extremes. And groundwater may play an important role for that. That's why our objective is to development of a transboundary basin scale management instrument based on the groundwater modeling to identify the appropriate management solution in this context. As you know, the Limpopo River Basin is located in the southern part of the Africa, and it's covered more than 400,000 square kilometers, and agriculture is the largest water users. The basins covers 4 different countries. It's Mozambique, Zimbabwe, Botswana, and South Africa. And its elevation varies from 0 to more than 2,000 meters. As a first step for the simulating or optimizing or developing the groundwater model, we need to know the groundwater reserves. And that's why a specially distributed monthly groundwater reserves is simulated using water balance model called WEFE. And in this WEFE model, we simulate the monthly groundwater reserves by using digital elevation model, the land cover map, soil map, slope, groundwater depth, potential evapotranspiration, rainfall, temperatures, and the wind speed. Here, groundwater depth are used to calculate the groundwater evapotranspiration in these water balance systems. And this WEFE model is a semi-physically based, especially distributed water balance model, and where groundwater resource is calculated as a residual term of the water balance for each cell. Now, if we check the result of the simulated groundwater resource, as you can see, the resource follows the rainfall distribution. When rainfall is high, resource is also high. When rainfall is low, resource is also low. And there is no long-term increasing or decreasing trend in the rainfall or in the groundwater resource. This figure shows the this figure shows the annual groundwater resource. And as you can see, annual groundwater resource is changing from 0 to more than 450 millimeters. And the higher groundwater resource in this area could be explained by the higher rainfall in the same area of the Limpopo River Basin. This can also be explained by using the land cover map of the Limpopo River Basin. As you can see, there is the mixed forest area on the same area of the Limpopo River Basin, and normally mixed forest area has higher groundwater resource compared to other land cover. On the other hand, the low groundwater resource on the other side of the basin could be explained by the low rainfall of the Limpopo River Basin, and it could also be explained by the soil types of the basin. And as you can see, there is a clay type material in this area where the groundwater resource is low, and normally clay type material has a lower groundwater resource, and it makes sense. That's why we are saying that groundwater resource responds to rainfall, land use, soil, and other processes. Although groundwater resource is quite high on the annual terms, as you can see, more than 400 millimeter resource. However, the resource is not uniformly distributed over the year. As you can see, there is almost no groundwater resource in the month of April to September, while higher groundwater resource are happening in the month of November, December, January, and February. This could also be explained by the rainfall distribution. As you can see, because of the higher rainfall in the month of November, December, and January, February, higher resource is happening. On the other hand, low resource is happening on the month of May, June, and July because of the very low rainfall. This figure shows the resource deviation from its normal, while the red color is showing the red color and yellow color is showing the drought event, and the blue color and the green color are representing the excess groundwater resource or the flooding event. Now, if we compare this event with this historical flood and drought, you can see this drought event are representing the multi-year drought in 2015 and 16, while this one is representing the drought in 2019, and these two are representing the flood in 2014 and 2017. That's why we are saying that historical flood and drought has a direct relation with the groundwater resource and deviation. Now, using this groundwater resource, the simulated groundwater resource, we are going to develop a conceptual groundwater flow model. For that, we need to know the geological environment of the Limpopo River Basin. And this figure shows the geology of the Limpopo River Basin. As you can see, the basement is the dominant geology in the Limpopo River Basin, although there is a sedimentary materials in the Mozambique parts, and also there are some volcanic or other materials in between the basement. Now, if we check the cross-section of the geological environment, again, you can see the basement is the dominant, and there is clearly there is 2 or 3 different layers in the geology. And near to the Limpopo River, there is a unconsolidated sedimentary or alluvial superficial materials near to the all the Limpopo River Basin. And above the basement, there are in some places there is a volcanic materials, or in other places there are some unconsolidated sedimentary materials. Now, using this geological information and the groundwater resource simulated by using WEFE model, we are going to develop the conceptual groundwater flow model. And for the conceptual groundwater flow model, we use the MOT flow model. And we consider a 3 layers model with a grid size dimension of 1000 meter by 1000 meter. And where we don't know exactly the depth of the aquifer depth, that's why we consider the first top 10 meters as a first layer with a confined and unconfined switchable layer. And the second layer we consider from 10 to 50 meters with a confined aquifer, and from 50 to up to 150 meters, 100 up to 120 meters we consider as a confined bottom layers. And digital elevation model has been used as the top elevation of the upper layers. We consider the no flow boundary, means there is no interaction between the model domain and the environment, and all over the area except in the near to the seaside, where we consider the constant head boundary near to the Indian Oceans. For the conductivity, this figure shows the horizontal conductivity for the layer 2, and this is the vertical conductivity for layer 2. As you can see, basement has the lowest conductivity, while the sedimentary basin has the highest conductivity. In general, vertical conductivity is 1/10 of the horizontal head conductivity, except for the basement. For the basement, we consider the same vertical conductivity as for the horizontal head conductivity. Conductivity for the first layer is different than conductivity of the second and third layer, and the difference is the conductivity of the first layer is 1.5 times higher than second and third layers. On the tops of the model, we consider the spatially distributed resource boundary that has been simulated by using WEFE model, and that we used as a top boundary of the conceptual groundwater model. All the major rivers are considered using a river package of the mud flow model, while the secondary and tertiary river are considered using the drain package of the mud flow model. Here are some results of the calibrated model. As you can see that during the calibration, there is acceptable agreement between the observed and simulated head, and where the yellow color are representing the third layer head, and the green color are representing the head of the first layer, and the others is representing the head of the second layer. Now, if we go in details by layer, then you can see in the third layer, there is a good agreement between the simulated and observed head. And if you go in the second layer, again, there is a very good agreement between the observed and simulated head. And now if we go in the third layers, although there is a very good agreement between observed and simulated head, however, there is a systematic overestimation, as you can see in the first layer. Although the goodness of fit between the observed and simulated head is very good, as you can see in the figure, however, the residual is quite high. As you can see, the residual goes up to 200 meters, which is quite high. And that could be one of the reasons, because so far in our model, we didn't consider the groundwater abstraction. Unfortunately, we don't know the groundwater abstraction of this area, what are the exact location of the wells and amount of water abstracting. We don't have all this detailed information. However, we know the yield of the different borehole. That's why we used the different borehole, more than 10,000 borehole across the Limpopo River Basin. And based on the depth of the borehole, we distributed them on the 3 different layers. As you can see, most of the wells are located on the second and third layers. And now, considering the yield as a representation of the groundwater abstraction, we are going to use this in our models. Now, if we check the rank percentile of this yield of this from this more than 10,000 borehole across the Limpopo River Basin, you can see most of the well has less than 10 liter per second yield. And you can see, if we zoom it, you can see this almost 90% of the well has yield less than 10 liter per second. Now, if we use this data in our model, you can see, in general, it's improved the groundwater model simulation capacity. It increased the goodness of fit. However, there is a significant overestimation for few wells, especially for the layer 3 and layer 2. Now, if we focused on those specific zone of this second layer and third layer for those area, we can see where are those. These are the wells are indicating here with the underestimation of more than 400 meters residual. And you can see all of them are in second layer and third layer. And why it's happening, this could be because of this higher grid cell. And because in our models, we consider the thousands by thousands meter grid cell. And because of this higher grid cell dimension, more than one wells are abstracting from the same location. And as you can see here, more than one wells are abstracting from the same location. And that's the reason why in some places there is a significant underestimation. And this problem can be solved by using multi-node well package, which we are trying to do now, and we are improving it now, and we cannot explain all the details because of the time limitations. And our next step is to develop the transient models, and that's what we are doing. With that, here are some conclusions. The conclusion is that historical floods and drought have a direct relation with the groundwater resource deviation. And a statistical indicator confirms that a good simulation capacity of the models during the calibration periods, and hence the model can be used for the future scenario analysis to identify the appropriate management solution and to improve the resilience to hydrological extremes in the Limpopo River Basin. However, the one of the major challenges remains this is the sufficient data in terms of the availability, accuracy, and spatial and temporal resolution remain the major challenges in doing this transboundary basin scale model. Before I want to thanks everybody, I want to just give you an announcement and information that we are planning to organize a virtual transboundary stakeholder workshop to discuss about our model conceptualization and also to identify the appropriate management scenarios. And please contact me if you are interested. In fact, the first transboundary stakeholder workshop has been planned in the first week of May. Unfortunately, because of this coronavirus, this workshop has been postponed. I hope you will help us by participating in our upcoming transboundary workshop. And with that, I want to thank you, everybody. Thank you very much.
Thank you, Sayed, for that insightful presentation on the development of a regional model for a very important transboundary basin in the SADC region, which is the Limpopo River Basin. Participants and colleagues, let me once more again encourage you to please enter your questions in the QA box that you find at the bottom next to participants. You have a QA chat box, question and answer box where you can post in your questions. And at the end of this session, we have a question and answer session where our presenters will be happy to take your questions and we can discuss your concerns further. Without further ado, let me welcome our next presenter, Marcus. And Marcus is going to talk to the assessment of changes in irrigated land in the Kafula-Futa catchment and Pongwe Karst, Zambia during the years 2014 to 2019. Marcus, you have the floor. Thank you.
Sorry, I hope the video works now. Thanks very much for the introduction. My name is Markus Wale, and I'm also presenting on behalf of my colleague, Mumba Kolala. To give you a short background, I work for BGR, the Federal Institute for Geosciences and Natural Resources of Germany, and BGR is conducting with Zambian partners currently the Water Resources Management Authority, WAMA, and the Lusaka Water Supply and Sanitation Company, a technical cooperation project in Zambia, which is called GRESP since 2005. In the last project phase from 2016 to 2019, the study area was the Upper Kafue subcatchment in Zambia's Copperbelt province, and you can see the project area on the lower right. Okay, so and the investigations included an assessment of the water uses, and the object of the presentation today is to show you the assessment that we did of the area extent of irrigation in the study area during the period from 2014 to 2019. So a very short background about the study area. It's roughly 6,880 square kilometers large. It has quite high rainfalls, on average 1,100 liters per square meter per year. And you can see on the right-hand side that it has different areas. So we have area 1 and 2, which are belong to the Kafula-Futa catchment. And you can see area 1 is made of carbonate aquifers, which are potentially high yielding and used for water supply in Angola. But sorry, I did hear the Portuguese translation just now. So in Ndola, we have high-yielding aquifers that are used for water supply in the city, but not for irrigation. And in area 2, we have low-yielding and medium-yielding aquifers, so there's no potential for irrigation. And then we have area 3, which is the Mpongwe karst area, where we have high-yielding karst aquifers and the center of irrigation in that study area. So the method that we used basically makes use of the fact that in the main irrigation season in Zambia, in the dry season, there's virtually no rainfall. So that means that whenever you encounter in that period of the year healthy vegetation, you know that it's either irrigated land, very deep-rooting trees, wetlands, or areas close to rivers. So we can quite easily spot irrigated areas. So what we did was just using freely available software, mainly QRGIS, and freely available data to do the whole analysis. We started with the digitizing tools of Google Earth to digitize the commercial farming plots in the area that you can normally see by the big geometric structures, so big circles and big rectangulars. Then we used the USGS Earth Explorer to download Landsat 8 multispectral images for the dry seasons from 2014 to 2019 and used different band combinations to depict the healthy vegetation. And we also used the natural color image where you can see, of course, that healthy vegetation is green. And then we went through manually to these images, marking the areas that were irrigated, adjusting the areas if there had been some changes in the layout of the farms, and also determining the start and the end of the presence of healthy vegetation, which is important as it gives us a clue when the vegetation period started, when the crops were planted, which affects the crop water requirements. To assess these crop water requirements, we did the easiest thing that is available. We used the FAO's CropWatt software together with climate data for Ndola from the FAO ClimateWatt database to get a rough estimate of the crop water requirements. When we have these crop water requirements and we already had determined the area under irrigation, we multiply them and take into account a standard irrigation efficiency to get to a rough irrigation water demand or water use. So the results for the crop water requirements for this region of the earth are shown here. Basically, the farmers are growing wheat on the commercial plots in the dry season, and you can see that depending on the planting date, the crop water requirement changed. The later the planting date, the higher the crop water requirement as the vegetation period reaches more into the part of the year that is hotter, because the dry season in the beginning is a bit cold. And we also used the banana parameters from the CropWatt database to get an idea of the crop water requirement of the orchard farm that we had in our area. So that is the summaries of the investigations or the summary figures. On the left-hand side, you can see the area under irrigation, and on the right-hand side, the estimated water use. So we can see that the land under irrigation increased by 5 square kilometers in these 5 years that we, or 6 years that we have investigated, and it's roughly a 10% increase. This increase was mainly due to farms extending their irrigation activities, but also in some cases, new farms were developed. And you can also see that the district of Mpongwe, where we have the high-yielding aquifers, is by far the most important, while the other districts have hardly any or just low irrigation activity, but you can see their relative increase was much higher. Then on the right-hand side, for the estimated water use, as we don't take into account a lot of factors like the year-to-year weather changes, a lot of other things that we can't consider by this simple approach. We put the uncertainty bars to show you that there's a quite high variation, but currently the water use should be around 50 to 60 million cubic meters per year, roughly. So for the layout of the irrigation farms, you can see the changes from 2014 to 2019 on this graph in the two lower pictures. And since that's maybe a bit difficult, we highlighted one specific farm in the upper picture, where you can see that there was not only just an extension of the farm, but also a change in layout from bigger center pivots to smaller ones, probably to make better use of the area. So of interest for us is, of course, what water resources were used to irrigate this land. And of course, you can get some hints from the remote sensing pictures, but here we used our knowledge about the farms on what sources of water they used. So you can see that in the whole entire study area, about 57% of the area is irrigated using groundwater, while 30% are irrigated by the Kafue River. The Kafue River is a very important tributary to the Zambezi River. And to this area, study area, it's more or less an external water source because just a small percentage of the discharge in the Kafue River is generated in that study area. And then we have 13% from other surface areas. As mentioned earlier, you can again see that depending on where we are in the study area, there's big difference in the Mpongo karst aquifer. We have like 60% of groundwater use, while in the other two districts, only surface water plays a really big role in irrigation. So what conclusions can we draw from this simple study? We have seen that there's a general trend of increase in irrigated land in the area in these 6 years. Yet there's also year-to-year difference on farm levels. This is important because WAMA, the Water Resources Management Authority, charges the farmer fees for water abstraction and consumption. So for WAMA, it will be necessary to check the compliance of farmers with this easy method. But they should do that on an annual base because you can see that there are changes quite in a short time frame. It's foreseeable that in the future, the groundwater irrigation in Mpongo will be extended, which can be guided by WAMA by water permitting, because groundwater use now since a couple of years needs a permit in Zambia. But the problem is to evaluate the sustainability because there's hardly any long-time data. And so it would be necessary to do studies in that regard to find out how many water could be used sustainably. But at least currently, there's no strong signs for overuse in that area. For your information, there's also the likelihood that there will be new irrigation projects in other parts of the study area because there's a very big new dam, the Kafuda Dam, about to be finished. And then we expect then in these areas with low groundwater potential, irrigation will increase from the surface water source. A quick evaluation of the approach taken. So it is mainly, the main task was to make it as simple as possible. And we can, even with this easy method, we can determine the area under irrigation with quite high certainty. Of course, we need these distinct seasonal rainfall patterns, otherwise it would not work. It's low cost. The only thing that you basically need is a good internet connection to download all these very big remote sensing images. For the water abstraction, as I have managed before, there's uncertainty their amounts. So we have just a rough estimate, for example, because we can't evaluate how much the supplementary irrigation in the rainy season is. So if there's a dry period in the rainy season, the farmers tend to irrigate to keep their crops growing, and we can't assess that with this method. So with this, I thank you very much. And if you are interested in the method, you can refer to the report by my colleagues, Mr. Karen Godau and Lungo Mesha. And that is available on our website. That is also put here on that slide. Thanks very much.
Thank you, Marcus, for that very enlightening presentation. Our next presenter is Mavuso Christopher Spanda. Mavuso, are you able to present? I see you are attending as an attendee instead of a panelist. I'm not sure if you can quickly cross over, or Dr. Kawawa Banda will present in his place.
Brighton, I've asked him to cross over as well. So I've sent him a new link. Maybe we can move to the next presenter if they're ready, and then he'll do it after.
Unfortunately, it's the last one, but transition, maybe we can take a few questions on the presentations that we have had so far. And once he's ready, we can have him present.
Okay, thank you.
Please, Mavuso, get in touch with Nazia, SADC-GMI host, and transfer your from an attendee to a panelist. There have been a couple of questions that have been posted. Maybe let me go scroll upwards and see what we have. Okay, so there's a question to Moti, which talks about the source of energy for the system. I see, Moti, you have responded to that one. You might want to take it. Please go ahead.
No, thank you very much. And thank you, Michael, for your question. As mentioned, because it's an artesian well, the water is able to be pumped into the elevated tanks, the 3 10,000 liter tanks. And then the water is reticulated through a pipe network through gravity. So we try to make, that's why we want to elevate so that it's possible for the water to go down, go to the field through gravity. In terms of the sustainability, the simple answer to your question is we don't know. Because so far we don't have actual data of that particular location over the 12 years that the location has been discharging water. As mentioned in my presentation, the artesian well has been discharging water for about, since 2007. And the interviews we had with the community seem to suggest that the flow has been consistent. But that's based on, the community interviews we conducted. There's no actual verifiable data other than the data that we have, which is the pressure checks I shared. We also have been tracking the flow rates, and we also occasionally check the water quality that is not changing across time. So this is one of the reasons why we said, even though the project is finished, it doesn't really cost much to go and monitor. So we're using our own resources as baseload to monitor, to actually see what are the changes across time and how is that affecting the other intervention, the community projects. And of course, we're working very closely with the local government to work with them in terms of trying to look for backup plans in the event something does happen. Like, for example, the pressure dropping to a level that is obviously not sustainable for the other community projects. So yeah, is it sustainable? We don't know yet. We still have to monitor. That's my answer.
Thank you, Moti. I hope that addresses the question. Then there's a question for Syed in the box that talks to what was the rationale for confining the groundwater modeling to the river basin boundaries Is this not an oversimplification? Syed? Syed, maybe your mic is mute. We can see you are talking, but we can't hear you, sorry.
Can you hear me now?
Yes.
Okay, thanks for the question. Before the answer, I just want to make a clarification. In fact, unfortunately, I have been present before the presentation and it was a miscommunication. That's why it was a pre-recorded version has been played. And there was some mismatch between the talking and the slide. And I'm sorry for that, for this difficulties and this. And the answer is, yeah, you are right. Maybe for the groundwater model is oversimplification, but as our main objective is to focus on the Limpopo River Basin, and also already is a huge basin. And if we want to increase it even more, it will be difficult for the groundwater modeling. And if we want to focus on the groundwater boundary, and we don't know exactly where is the groundwater boundary, and considering all this, and as our main focus on the groundwater for the Limpopo River Basin and for the resilience for the sustainable groundwater management on the Limpopo River Basin is the main focus. That's why we focused mainly on the within the Limpopo River Basin. However, we have a plan to go in the local sub-basin to downscale the model to see a specific solution for the local region, and then we will do for the maybe based on the boundary of the groundwater flow for the local small catchment sub-basin model. Thank you.
Thank you, Syed. Apologies for that mix-up that you alluded to earlier on. We are happy that you are with us here. I've been told that our next presenter, Mavuso Christopher, is ready to present. Mavuso, if you can share your slides. Dear presenters for this session, please remain put. We'll take another round of questions before we close the session after this coming presentation. Mavuso, please go ahead.
All right. Thank you very much. Good morning, ladies and gentlemen. Welcome to my presentation. The title of our presentation is Preliminary Investigation of Groundwater Risk Culture Practices. This study is being undertaken by the CIFAS project, which is the physics. As we may know, agriculture is responsible for significant water withdrawals and overall consumption of water. And as such, groundwater becomes key as in an intervention, especially in the foreseeable impacts. And in order, it has been to, which is said to have several, include reducing land degradation, soil moisture conservation, geothermal regulation, and reduced field preparation costs. However, there's limited information on the effects of conservation tillage or agriculture on groundwater, especially below the field on which it's being practiced. This study was set up to undertake a comparative study of the effect of conservation agriculture, in this case, the tillage practice under conventional agriculture. Pardon a bit, my
Mavuso, are you there?
I'm here, but my okay. It froze. Okay. Fine. My apologies for that. Conservation permanent agriculture strategy for most of the smallholder farmers, and also for policy, it's being promoted in most of the developing countries, especially in sub-Saharan Africa. And as I highlighted, CA is being promoted over conventional agriculture because it promotes water infiltration into the soil, reduces water stress, which could limit crop yields. And also under CA, the unutilized water, instead of being generated into runoff, it is channeled to recharge the groundwater. So it's from this thought that a further investigation could be necessary to see what is the actual effect on the groundwater. Now, the objective of this study, this work represents the framework of the hydrology work group of the CFAS project, which, as I said, it's the strengthening capacity, environmental physics and hydrology and statistics. And the work package objective is to establish if there are differences in groundwater response under the two management practices. So this slide highlights the setup of the sites where we are. This is in Kaveleka, in Chongwe of Lusaka district. Yeah. On the mid photos there, on the left, there's the CA field, which is the conservation agriculture field. And on the right, we have the conventional agriculture field. And that's the aerial setup. In between, you have the homestead of the farmer there. So the Liempe, we have a site also in Liempe, which is the University of Zambia farm, and Kabeleka, which is a village in Chongwe district. But there's also a setup in Chiteze, Malawi, which is at Chiteze Agriculture Research Station. And we have another site in Zimbabwe at Domboshava Training Center. So the three sites are all looking at the conservation tillage and the effects on groundwater, and also with the comparison on the conventional tillage. So in terms of the study setup, there are paired investigations on CA and with one where C Now, investigations on include consideration of which is the soil group, and we also have which is being considered by the shallow geophysics group, and we also have the a deeper surface. Installation on each sites include a weather station and rain. We've got, in this case, for example, at Kabeleka, we have 7 boreholes and 6 boreholes in the, it's about 40 meters. Transducers to measure water levels. Complementary installation from the wider. We also do ERT installations, or with, in some sites they are done, they are mobile. In some cases, they're permanently fixed and measure continuously. Then we also do aquifer tests, pump tests, and potential information of the hydrogeology properties, and also being downhole ERT measurements to obtain additions on drawdown behavior. Observations of the water levels, that is comparison of recharge. We're also doing water sampling, where we're time tracers and isotopic changes. And also we're looking at changes in the hydrochemistry of the groundwater. Sorry, it has frozen again. Okay. Yeah, so as for the preliminary data so far, it indicates that groundwater, there are some differences in the groundwater levels when you look at the conservation agriculture and the conventional agriculture. On the top left, the green curve is the CA, while the red is the conventional one, and the rise of the green curve was on a slightly higher plane than the conventional one. Though as they receded, it seems in this case, the conventional tillage moisture was slightly on a higher plane than the CA, but I'm sure the details of this will become clearer as the more data come up. So there's steeper initial water level rise in the beginning of a recharge period under conservation agriculture, but the recession, it comes lower than the conventional. And also we have preliminary evidence from the isotopic composition of the groundwater. So different isotopic signals might be indicative of differences in recharge mechanisms. So in terms of the next steps, further data is being collected until the end of 2021. Then we are going to do pump tests at each of the 3 sites at the end of the project in order to estimate aquifer properties. Groundwater recharge estimates will be completed, and then complementary data for soil moisture in the upper 1 meter of the unsaturated zone and observations on changes in electrical resistivity of the subsurface will aid the overall interpretation of the data. And that is now the affiliate partners to the CFAS projects, which represents the members of the hydrogeology group. As they are listed there. Thank you.
Thank you, Mavuso, for that presentation.
Thank you.
Yes, for that presentation, and colleagues, attendees and panelists, the 4 or 5 presentations that we had for this session to kickstart our sub-theme 1 of the conference. We have the panelists, or the presenters, let me say, ready to take questions. You can add your questions, follow-up questions to the reactions that we have had when we're waiting for Mavuso. Otherwise, that is it. While we are waiting for questions to come into the chat box, I have a few questions for the presenters. Maybe the first one goes to Syed. Syed, you are working in the Limpopo Basin, and one issue that you might have come across is the issue of challenges with access to data, or the lack of data that you might need to complete your modeling exercise or your modeling project. Briefly take us through some of the challenges and how you intend to circumvent them.
Okay, thank you, Brighton, for the question. And indeed, it is a great challenge to have a sufficient data in terms of its quality, spatial distribution in the large scale model. And for example, one of the major challenge is the groundwater abstraction data. And we don't know very details about the groundwater abstraction data from that area. That's why we are using yield as a representation of the groundwater abstraction, which is not always correct. And as you can see, when we started implementing the groundwater abstraction in our models, and although it improved the model simulation capacity, However, it's at some places it's significantly underestimating, and because we don't know exact information about that. That's why to have details information about the groundwater abstraction would be very nice. Thank you, Brighton, for providing. At least we have some data now, borehole location and static water level and all the yield, borehole yield data that we have. Thank you, SADC, for providing all this support. However, to have more information on groundwater abstraction and the time series of the groundwater level would be very helpful to improve our modeling in this area.
Thank you, Syed. Thank you for that response. And my follow-up question that I would have to you, please, colleagues, remember to post your questions. We still have a couple of minutes to fill in a number of questions. So I'm actively checking the Q&A box for any new questions. Feel free, the presenters are still here. They will happily take your questions. I might have missed this, sorry. The modeling package that you are using, which package are you using and what informed that choice of that package? I'm assuming I heard you say you are using the ModFlow package. And
yeah, maybe you are asking me, and that the thing is that I'm using ModFlow model, ModFlow package, and for modeling we am using FlowPy package, but it is a ModFlow model. And the reason behind is because in this area, this different management scenario, especially based on the reservoir and dams and their effect in future, and we can easily implement in the ModFlow model. That's why we chose these types of models, so that we can implement the different management scenario to ensure the sustainability of the groundwater and to increase the resilience to hydrological extreme. And different types of scenario could be easily implemented in this model. That's why we chose this model. I hope that answered your question.
Okay. Thank you. I see my co-chair is here, Professor Kinabatho. You might want to chip in if you have been following the presentations. Any reactions?
Thank you, Brighton, and thank you for standing in. I think first of all, I think the Q&A is somehow disabled now. So I think that's why you can't see any additional questions or comments. My question was also going to go to Syed, particularly on his work in Limpopo. And I wanted to ask him that since he's dealing with a transboundary issue here, there are many other efforts within the Limpopo that are addressing transboundary groundwater issues, mainly driven by the IMWI and some work that SADC-GMI has done. So how are you linking with these efforts in order to make a synergy between your work and what is already going on? Thank you.
Yeah, thank you very much for the question, and indeed is a very good and important question. And one of our objective is to make some transboundary workshop and also regional workshop, so that we can incorporate all the available information and feedback from the different stakeholders. And at this moment, we are planning, or let's say we are in the initial stage of we are thinking to organize a transboundary workshops so that everybody can contribute, like the people from IMI and other institute who has been working in this area for the groundwater sustainability for a long time, and who has the more information than in some aspects than us. And I will be very happy if everybody can join and then contribute for the further development of our models and our scenarios, because we are just at the end of the model now, and we need to identify the appropriate scenarios to check which scenario will be the good for the sustainability of the groundwater management, and also to improve the resilience to the hydrological extreme. And the contribution from all the stakeholders will be very highly appreciated, and we are very open to accept all the positive contribution, all the positive feedback from the different organizations.
Thank you. Maybe I'll leave it to you, Prof. Kenabatho, to take further questions and probably wrap off the session. Thank you. You're on mute, Prof.
Yes, sorry again. I was saying thank you, Brighton, again, for a good facilitation on the first part. I think I would want to assume that if there is any Q&A questions and comments in the screen, I can't see any. And I think let's take this time to appreciate and thank the participants as well as the presenters for this session. One of the key issues that came very clearly is that there is a need to move towards integrated management of transboundary water resources, in this case, particularly the transboundary aquifers. And it's a challenge to all of us that are doing research in different parts of the world and also in different areas of specialization. So I want to encourage the collaboration moving forward, particularly linking with institutions that are spearheading this work, in this case, the SADC-GMI, and I think we should really appreciate their efforts. I think there are many other transboundary aquifer assessments that are ongoing, but I think we shall hear more of this in other sessions as we continue with the program. So once again, without any further ado, I think Brighton, if you allow, we may have to close this session so that we move on to other sessions to save time.
Thank you, Prof. I think we are done with this session. Over to you. Thank you.
Okay, thank you very much, Brighton, and the rest of the speakers. In the next 15 minutes, it's a comfort break. And please be reminded that you need to complete those attendance register forms and the forms for the special session as we have announced. So in the meantime, we are going to take about 15 minutes. I see now it's 8 minutes past 11. So we'll be back at around, let me say 25 past 11. I think that's fine with everyone.
Yes.
Thank you.
Around 25 past 11. Or should we make it half past?
I think that's fine. 25 past is fine.
25 past 11, we are all back. Thank you very much.
Yeah.
Thank you.
Thank you.
Thank you.
As you can see, we are far much ahead of our schedule. And we are now going to take the next session, which is going to be chaired by Trevor Shongwe, assisted by Svashni Naika as a rapporteur. I hope the colleagues that are going to chair the session and the rapporteur, you are ready. Trevor, I'm handing over to you. Thank you.
I believe it's still a good morning to all. Thank you, Chair. I hope, Chair, you can pick my voice.
Yes, you can go ahead.
Thank you, Chair. With that, can I then? Oh, what's happening here? Can I request, Chair, that we proceed with the next?
Yes, go ahead, Trevor. You can proceed with the session. Thank you.
Chair, Trevor is now mute.
You are on mute, Mr. Shongwe.
Sorry about that, Chair. Chair, I was saying we have 5 sessions or 5 papers, 15 minutes each, and we have 1 hour, 15 minutes. The first paper is coming from Diana and is looking at comparative studies on the estimation of groundwater recharge under conservation agriculture versus conventional tillage. And may we then give now the opportunity to our presenter to lead us through this first session. Diana, may you take the floor, madam.
Thank you. Good morning. I'm here to present a review of the comparative studies estimating groundwater recharge under conservation agriculture versus conventional tillage. And I'm a postgraduate, or I'm a doctoral student at the University of Zimbabwe. And I'm also a member of the hydrogeology working group on a project called CEFAS, which I'll talk about a little bit later on. And this is the group that I'm representing in this presentation. So as a background, when we look at how the climate is changing, we are in an environment where there's an ever-changing climate, increased occurrences of droughts and failure of crops, and food insecurity has become a challenge, particularly in the SADC region. When we look at just the El Nino effect of 2015, 2016, there 27 million people of the SADC region were indicated as being food insecure as a result of that drought. And looking at that particular drought as well, surface water balances were in a deficit, and that suppressed groundwater recharge. And this was the launching pad in terms of the project that we are on. And when we look at coping mechanisms, however, in the SADC region, governments in the SADC region are more and more promoting climate smart agriculture or agronomic systems, the expansion of groundwater irrigation. And in those climate smart agricultural techniques, conservation agriculture is one that is being promoted. Even in my country, in Zimbabwe, it's gaining quite some prominence. And when we look at CAA, it's minimum soil disturbance or no tillage, and crop or surface residue retention, and crop diversification. So that CEFAS project I mentioned is that CEFAS stands for Strengthening Capacity in Environmental Physics, Hydrology, and Statistics for Conservation Agriculture Research. And on the CEFAS project, we have a number of representatives on this project who are coming from the British Geological Survey, as well as other universities within the UK as well. And that includes University of Nottingham and University of Zambia, Zimbabwe, Malawi. And we're including research scientists that are statisticians, scientists, geophysicists, hydrogeologists, agricultural practitioners, and social scientists. What are we looking at? We have a key question, and that is, what is the impact of climate smart agriculture, and in particular CA practices, on soil water dynamics, agricultural resilience, and groundwater recharge? And for us in the groundwater group, that component of groundwater recharge is of interest. Do we know the effects of conservation agriculture on groundwater recharge? And is there existing literature on the subject is where we started off, particularly with this review. And what does this existing literature say? What is it telling us? So we conducted a literature review, and the aim was to look at what studies are existing and what are they saying. So it was what is available. And of course, we had keywords, and we used Mendeley as our reference managing system. Out of the manuscripts that we looked at, in the end, we had a total of 34 studies that met our criteria. And in there, we're including all crops that were grown on conservation agricultural type of plots, as well as conventional plots was a key thing, to have studies that compared those. and those that looked at measuring certain parameters such as infiltration, deep drainage, percolation. Recharge, of course, was what we were looking for, but where we didn't find that, we looked at proxies for measuring groundwater recharge. And in the end, those 34 studies is what we looked at more closely. And those 34 studies, we also analyzed what was happening with respect to the groundwater recharge techniques that were used, whether using direct methods or indirect methods, as in whether they're measuring fluctuations within the groundwater or the saturated zone and direct techniques, or were they using techniques that measured within the surface and the unsaturated zone. So that was of importance to us when we were analyzing the results of some of these studies that we looked at. And when we were extracting information from those studies, we were extracting the location, where were these studies located, and we found that most of the continents were represented in some of the studies that came up within our review. And we also found that, or when we were analyzing, we were able to look at what is it that they measured, what parameter was measured with respect to those soil or groundwater fluxes. And we were indicating in our results whether they indicated that there was higher infiltration or recharge or drainage within the zero-till or no-till plots, or did they find that the conventional tillage plots were the ones that indicated higher groundwater recharge or soil water in the areas that they measured. Some of the results that we found in terms of the studies that came up were, of those 34 studies, only 22 of those studies were actually studies where there were specific sites. So those sites I showed were those 22 sites. The other studies were also reviews, and we used those reviews to compare the results that we were coming across. And the majority of the studies were found in America. North and South America constituted 41% of the studies, which makes sense, because when you look at some of the information that we have in 2008-9, 85% of what was conservation agricultural areas were still within the American region. And with Africa, only 0.3%, according to studies by DEPSIA in 2010, were still representing those conservation agriculture within globally. So not as many of our areas are being managed under conservation agriculture as yet. 27% were the manuscripts that we found for Africa. When you look at the parameters that were measured in those 22 studies, only 2 of the studies had actually calculated or measured groundwater recharge. Infiltration was the most common parameter measured, and was measured in about 50% of those studies. And when you include drainage or deep drainage, that's about another 14%. So 64% were measurements that we could use as in perhaps indicating water that would move into the groundwater storage. So potential groundwater recharge of CA versus CA, conservation agriculture versus conventional, and 55% of the studies that we looked at overall said that there was higher potential of groundwater recharge with conservation agriculture with zero-till or no-till as compared to 32% that indicated that it was higher with conventional tillage practices. 14% of the studies, however, said there was no difference between the groundwater fluxes, whether conservation agriculture or conventional. And this corroborated with other results that we were finding in the reviews with Ward and SADC also indicating that they also found generally majorities of the studies indicated higher potential for groundwater recharge with CA. Edwards in 1990 indicated that there was even an additional 100 millimeters per year of recharge that would come in watersheds that were managed under conventional, conservation agriculture as conventional tillage. So when we look a little bit further at analyzing those infiltration and drainage rates from the studies that we found, 47% indicated higher potential in zero-till and no-till, as compared to 33% that indicated higher in conventional tillage. 20% indicated no difference. So again, it's very close similarity to what other studies found. In Africa, there were manuscripts that indicated, some of that, in that 60% of the manuscripts were also corroborating with the higher potential groundwater recharge in conventional, in conservation agriculture rather than conventional. When we moved to the American studies, however, it started to change, where more of the studies were being found that conventional tillage was responsible for higher groundwater recharge calculations. A note on infiltration from what we were looking at. We were saying heavy reliance on the unsaturated zone studies is what we found within these manuscripts. And it's important there for us to note or to remember that lateral movement of groundwater is still possible, even when we've measured infiltration and we're saying there's potential for groundwater recharge. The type of infiltration measurement method was also indicated as an issue there, and the time of measurement of infiltration, at which part of the season. A lot of the agricultural studies focused on studies during the rainy season, during the season that they were looking at the plants and the yields that they were getting, as compared to during fallow. So overall, we don't have a continuous record of what's happening within those fields. The type of CA practice used, we also found that not all plots that are managed under CA would use those three practices of zero tillage cover crops. Some of them would use only zero tillage and no cover crops or no residues. And that had an impact on the measurement found with respect to infiltration. The results of the two articles that we found that actually had a calculated or measured recharge didn't bring us closer in terms of whether we were actually finding ourselves. The one was done in the USA by Daniel in 1999, another by O'Leary in Niger. And the difference there was also the CA practices used. One by O'Leary also included no-till and residues. And the overall was that the one by Daniel in 1999 indicated higher recharge rates under conventional tillage. And yet the one by O'Leary indicated at least 185 to 186 millimeters per year of additional recharge due to zero tillage or no tillage practices. When we looked at the manuscripts that we had, again, those three core practices of CA and how they are implemented in those plots had an impact, where you would find that intercropping, where the plots were managed through zero till and intercropping, 100% of those manuscripts reported that there was potential groundwater recharge higher than on conventional. When you compare just zero till and no till, it starts to change, where there's 38% of the studies indicating that CA was promoting potential groundwater recharge, as compared to 46 with conventional tillage would be the one that promoted more groundwater recharge. So other findings and other reviews also indicated that although there's an overall increased hydraulic conductivity and infiltration rate due to no tillage, there were a few other issues as well. The soil type, what kind of soil are these plots being found in? And clogging at times, where you find that CA was in more clay type soils promoted clogging, and the hard pan formed, and that all had an impact on groundwater recharge in that the rate was decreased. When we look at the conclusions that we came up with, just looking at some of those manuscripts and comparing what other review studies had indicated, there's a lack of systematic evaluation of research studies. And we are recommending that when we look at studies that are employing techniques that measure groundwater recharge, because in manuscripts mentioned CA would lead to potential groundwater recharge. However, not so much backed by any measurements or any information. So we could support the agricultural studies that look at comparing CA and conventional or other climate smart agricultural techniques by supporting them with methods of including groundwater level fluctuations in terms of looking at more the saturated zone, environmental traces, use of environmental traces, use of stable isotope. And there is need to support and build capacity within our fellow researchers who are looking at climate smart or agricultural studies, so that we can have a comprehensive or a better idea of what's happening with respect to groundwater recharge. Just author affiliations, perhaps similar to the previous speaker before the study, and that's just indicating the institutions that we all come from. I would like to thank SADC-GMI for the opportunity to share some of this work that has influenced what we're doing within the CFIS project as the Hydrogeology Working Group, my CFIS colleagues, and the greater CFIS network. And then I thank you all for listening to this presentation. Thank you.
Thank you, Diana, for the wonderful presentation. And I take it that at this moment there are no questions because on the question and answer slot, there is nothing that is currently reflected. It's safe to say that there is one that is saying this is not a question. So I take it that the presentation was very straightforward, very informative, and to the point. But we'll still await any reactions in the case something can pop up later on from our distinguished delegates. May I then take this opportunity to thank our presenter and the team that she is working with on this wonderful presentation. May we then move ahead to our next presenter, who indicated that is actually available to take us through the next presentation, is Zahid, working with others. And is going to be presenting a paper on looking at localizing transboundary data sets using big data analytics. This is a case of the Ramotswa dolomitic aquifers. Rahid, are you available and ready to take us through the paper?
Good day, Chair. Can you hear me? And are you able to see my video?
Yes.
Can we mute our mics when we are not presenting? I think there is some noise coming in. I don't know from who, but there is some noise. So please let's mute our mics when we are not presenting or talking. Thank you. Continue.
Thank you. Thank you, Chair. Right? Continue, sir.
I'm just trying to share my screen quickly, Chair. Is my screen visible, Chair?
Yes, I can see something, many logos. If that is you, then we can see something.
Okay, perfect. Let me just do that. And let me minimize this, please. Okay, thank you very much. Thank you, everybody. Thank you for this opportunity to present at SADC-GMI 2020. My name is Zahid Kapoor from the University of the Western Cape, and I'm a PhD student, and I'll be representing the work that we'll be doing with regards to a big data and transboundary water collaboration within Southern Africa. So let me start. Thank you very much. So my title of my presentation is Localizing Transboundary Data Sets Using Big Data Analytics, a case study of the Ramotswa and Northwest dolomitic aquifers. And there are a number of partners that were involved in this research, which you can see now via the logos. So let me just start by saying, what is big data? Or what is big data analytics? So big data is a collection of large, heterogeneous, multi-dimensional data sets that are generated through modern technologies. Within the earth sciences discipline, these are essentially your remote sensing, your connected or smart sensor devices, your computer simulations such as global circulation models, land surface models, web-based activities such as social media and other internet pages, as well as the field activities from hydrological research. So these all together provide this, and once it's all together, we call this big data. And big data analytics is simply the techniques that we use to transform big data into information. Traditional analytics and statistical techniques such as data mining, data visualization, and mathematics in general are integral part of big data analytics. That is really where more modern big data analytic techniques such as machine learning and artificial intelligence has come to the fore to leverage these very big data sets. So in the context of this project, the problem that we're trying to investigate, or at least trying to solve, is that much of these big data that is coming from remote sensing in particular and land surface models, as well as your global circulation models, they're all regional in scale, in the sense that the resolutions are far too large or too coarse to provide localized data to support groundwater, to support sustainable groundwater management. As we all know, I mean, local scale data is often preferred to manage aquifers in our context and in Southern Africa in general. So we see that in the diagram on the right-hand side.
Said?
Yes?
Sir, I think the sound quality is not that good. I'm not sure if there's something that you can do on your side. The sound quality is not that good. That's what we are receiving.
Can you hear me now?
It's much better.
Chair, are you able to hear me now?
Yes, it's clear now.
Okay, perfect. Sorry about that. So let me just continue where I left off. So on the right-hand side, you'll see the diagram, which shows you that depending on the scale you're looking at, the type of data that becomes more relevant when you're looking at regional scales, your roster data sets and your regional remote sensing and land surface model data sets become more important. But as you zoom into a local scale, your ground observations that are in situ become more pertinent. And we want to get to a stage where we can integrate local and regional data together to improve predictions and improve groundwater management decision making. And how we're going to do this simply is that we've developed a what we call a transboundary aquifer analytics framework that we're using to integrate the local data and the regional data. It starts with a selection of our case study area and then moves on to establishing of groundwater management or sustainability indicators that's taken out of the California Sustainable Water Plan. In this particular case, we're looking at modeling water levels in order to understand a chronic lowering of groundwater levels within the study area. And once we know what we're studying and what parameters we look at, we can connect to relevant data sources and these big data sources that are located across the world. And once we have that data, we can then put it through a process of modeling learning context to determine or at least predict the groundwater levels. And once that is done, then we can downscale the data and that should provide us at least with some information to improve our management decisions. So our case study area is the Remotswa, Ceres, Lobotswe, as well as the Northwest Dolomitic aquifers that are situated in Botswana and South Africa. Parts of the basin or parts of the aquifer are transboundary in nature. It's a predominantly karstic aquifer that is very highly compartmentalized. And one of the most important reasons why we chose the study area is that there are issues of over extraction in the basin, in the aquifer, that's leading to chronic lowering of groundwater levels. And this is why we also chose groundwater levels as our modeling parameter. So these are the data sets that we've included in our machine learning model, which I'll describe a little bit later. But it involves land surface data sets that coming from the ERA5 land surface model, such as soil moisture, precipitation, runoff, evapotranspiration, and land surface temperature. And then there are our remote sensing data sets that are coming from the GRACE mission, as well as the global land data assimilation terrestrial water storage that's coming from NASA. Groundwater levels that have been collected from the Hydra and RIMS and NGA databases. And then our hydrogeological features such as the compartments of the aquifer type, as well as land surface features such as land cover that are all included in the model. We've done some pre-processing early on to convert these values or the data into daily values, as well as some unit conversions into so that all the units are the same. Some of the other pre-processing that has taken place is the extraction of the GRACE groundwater signal from the GRACE data, as well as converting or formatting the groundwater levels into 30-day groundwater level changes. And this is the target feature. This is the feature that we're trying to predict using all the other data sets that are shown in this table.
Beyond that, we went through another phase of pre-processing. So with that data that was displayed previously, we extracted a number of features that are used to predict the 30-day groundwater level changes. And these features are simply aggregations, 30, 60, and 90-day aggregations of precipitation, evapotranspiration, runoff, as well as mean averages or averages across 30, 60, and 90 days for soil moisture, land surface temperature, and groundwater storage, which is coming from the GRACE data. Your categorical features such as aquifer type, compartment the data belongs to, and land cover are obviously categorical features, and there's not much pre-processing involved in that. So now while we talk about the machine learning algorithms, the type of algorithm that we employed is called the gradient boosting decision tree. And in very simple terms, the image on your right-hand side is displaying what the decision tree is in its very simplest form. It's simply decision versus condition and probability outcome decision tree. So this simple example shows you how we determine whether someone on the Titanic will live or die depending on a set of conditions. And that's a simple decision tree. In very technical terms, you're basically dividing the predictor space that all the data belongs to based on these set of conditions that reaches an outcome or in this case, a prediction. And the model trains by backpropagating the prediction error through successive iterations. I'm not going to go too much into that, but just to let you know that these models are very accurate, they're highly efficient to run, and they provide us with a set of properties that are easy for us to work with in the context of our data, such as handling missing values, which we have, outliers within our data set, and irrelevant features that might be coming within the data. So that is why we've chosen this particular model. And how we use this algorithm is simply this. We're trying to develop a generalized model that can be used to predict 30-day groundwater level changes at any locality in the study area based on those set of input variables which I've shown earlier. The process starts with some subsampling, so removing or reducing the number of records per borehole such that there's only 1,000 records per borehole, so that no model has a greater influence in any other, no borehole has a greater influence than any other borehole in the data set. And then we split the data according to the borehole into training and testing. And the testing is used, obviously, to test the model at the end of its development, and the training is used to train the model. But before this, we go through a process of hyperparameter tuning, which is simply to optimize the settings that the GBT is based on, or the gradient boosting decision tree is based on. And once this is done, we go through 100 different iterations based on the random splitting of the boreholes between the training and the testing. So across each iteration, there's a different random splitting of boreholes between the validation and the training set. The idea behind this is that no model, no iteration should at least perform any different between the iterations, so that there's at least a generalized idea depending on whether the boreholes are in validation or in the testing phase. This is to ensure that there's generalized idea behind the models. And once this is done, we go through the 100 iterations and we test the model at the end of the day. And the model that performs the best is the one that we use forward to predict the groundwater level changes across the entire study area. So once the model has been trained and we've chosen the best model, on the left-hand side, you'll see a table which shows the top 10 iterations, and we see that model number 16 produces the lowest or, and this is mean absolute errors. So in general, for model 16, there's a mean absolute error of 17 centimeters in our prediction, in us predicting the groundwater level changes at 30 days. On the top right-hand side, you'll see a scatter plot, which shows you the prediction versus true values. And we see that there's still some issues of extreme values, predicting extreme values. This is one of the consequences of us having taken out or removing the outliers during pre-processing, but it's also a consequence of the model itself and the spread of the data within the data set. So this is something we still need to consider. And in the bottom right-hand side, you'll see the feature importance that was generated during the model training. And we see that land surface temperature and GGWSA is simply the groundwater storage, and GMA is the compartment code. So those three features are the most influential in accurately predicting the 30-day groundwater level changes. Surprisingly, across the entire study area, or across the entire 100 models, the groundwater storage was, in fact, on average, the most important, followed in turn by the land surface temperature. But in this particular case, the land surface temperature was more important. On average, the models produced a mean absolute error of 33 centimeters. So these are all the 100 models. Their training scores had an average of 33 centimeters of prediction error. So once we've now chosen our best model, which is model 16, we then apply this to calculate the monthly groundwater level changes for every grid cell in the study area. And on the image on the left-hand side is displaying the center point of the grid cells, which are at a resolution of 5 kilometers at the moment. So we've downscaled to 5 kilometers, or at least attempting to downscale to 5 kilometers. And on the right-hand side, it shows you the net groundwater level change based on the monthly predictions that we've done at every grid cell center. So that you see basically that there are considerable groundwater storage, groundwater level declines across the study area. And in some compartments, if you're able to see my mouse, there are considerable groundwater level declines compared to the other areas. We see also that the compartments have a huge influence on the prediction, in the sense that between compartments there's a different prediction. And in some places there also rises in groundwater levels. Moving on to the next slide, and once this is done, we then validated our results. So what we did is we calculated using observed groundwater levels from the boreholes, the monthly groundwater level change, and we validated this against the modeled groundwater level change. So that you see on the image on your left-hand side, the map, that there is in general a good validation between modeled groundwater levels and actual groundwater levels across the study area. In fact, on average, there is a 17 centimeter prediction error across the study area for all predictions. But this is not the whole case or the entirety of the issue. We see that on the top right-hand side, there is a number of boreholes that are that predict well, and on the bottom right-hand side, you see that there are a number of boreholes that predict very poorly, and surprisingly, the boreholes that predict very poorly are located in one part of the study area, and we believe this is a consequence of abstraction, which is not taken account into the models. So that illuminates some information for us to look into in terms of groundwater management, where these in this particular compartment of the aquifer. So that's an interesting insight that's come out of the modeling process as well. And that's the end of my presentation. Thank you very much.
Thank you very much, Zahid, for the wonderful presentation, taking us through what has been done in actually assessing the behavior of this aquifer as far as groundwater monitoring is concerned. May I indicate that the question and answer slot is still active for the participants. You can post your questions there, and then the panelists will attempt to answer their related questions. But with that, we have the question and answer slot at the end, or at the end of the different presentations that are coming through on this particular slot that we have. May we then request that we move on, and in moving on, we then take the next paper, which is going to be coming from Lars Lars Andersen is going to be looking at the significance of Danish advances in the groundwater management and use. I take it that our next presenter is ready, and may we then give him the floor to take us through his presentation. We can see that the question and answer session or slot is actually indicating some numbers. So may we invite the presenters to check and then be ready with their responses at the end of the presentation. Lars, the floor is yours, sir.
Thank you very much, Mr. Chairman. I'm going to talk, I'm presenting this on behalf of the Danish Water Forum. And my water experience started at the University of Zambia in 1980s, where I helped to establish groundwater as a major part of the curriculum, together with my Danish colleague Jørgen Knudsen and Dr. Chisengo Ndala, who had recently returned from the US with a PhD in geophysics. Now I'm talking from my country house in Denmark, and this is really a very, very great progress that we have seen since the 1980s. In 2006, I returned to Zambia as advisor to the Ministry of Energy and Water Development. And at that time, I helped my former student. Since then, he had become professor at Imasiko Niambe to establish integrated water resources management at the University of Zambia. Today, I'm retired, but I'm still active as responsible for the EU-China dialogue on groundwater management. The reason I'm talking today is that the Danish Water Forum and the Groundwater Management Institute, we are in the early stages of entering a North-South groundwater partnership to exchange experience and knowledge that we have on our groundwater management in Denmark and what is the present status of groundwater management in the SADC countries. And this will be a contribution, first of all, to the target 6.1 to improve or increase the access to safe and affordable drinking water. But in itself, our cooperation is a global partnership and also contributing to the Sustainable Development Goal 17. So this is the framework where we will be working. In Denmark, we often pride ourselves for saying that we have the best groundwater management in the world. This is both a pride and a need, because we depend 100% on groundwater for all our water uses. And I think it's very few nations in the world who are in this position. Of course, we can do so because we have no irrigated or very little irrigated agriculture. And because of the advanced state of our groundwater management, I think we are obliged to share this experience with the world. And the Danish Water Forum has just entered an agreement with India, and now we are working to enter one with the SADC member countries through the Groundwater Management Institute. You have ample groundwater in Africa for rural water supply, and I can see that a lot of you consider groundwater as the savior for future agriculture. But I should also want to emphasize from my work with China that on the North China Plain, the water level is... Yes?
May we request to interrupt your presentation? Do you have any screen to share?
I should have shared the presentation. Sorry.
We are seeing you on the screen, not to the presentation.
Okay.
May we request that you share the screen?
Yes, sorry about that one. Is that on now? Yes.
It is on now. You can proceed.
Yeah.
Sorry about that.
No, that's my fault. Sorry about that. Okay, so as I said, you have ample groundwater in Africa. Actually, this is a graph originally made by one of the previous speakers. But I should also say that on the North China Plain, the water level has fallen 1 meter per year for more than 50 years. And you can see this as and this means that this area which was the food basket of China originally, is now converting all its agriculture into forest. This, of course, coincides with the advent of submersible groundwater pumps. And this is a dire warning to you as you expect to develop groundwater for rural water supply. The other aspect that I have discussed with James Saramba is that there's still a perception around the world that hand pumps is the appropriate way of developing rural water supply in Africa. And we think it's really time that you move to more advanced technologies, first of all, like the solar panels systems, where I installed one in Sudan in 1990, maybe one of the first in Africa. And now, of course, to water kiosks that are developed, in this case, by Grundfos of Denmark. And these are already working in Tanzania, and I know that they are on their way to being introduced in South Africa. Groundwater in Denmark stems back from the 1850s in response to the cholera in Europe, 1835, 1865. And then Copenhagen decided that it was going to move into groundwater. Copenhagen was a filthy town at the time with wastewater flowing in the streets and into the lakes surrounding Copenhagen, from where the water supply was taken. So obviously we also had cholera in Denmark, but it was a disaster that actually turned into an opportunity for those of us working with groundwater. At the same time, we had the emergence of rural cooperatives in Denmark, and this was mainly the farmers deciding that they were better off to produce their dairies and slaughterhouses, mainly for export to the UK, and this was the start of the agricultural revolution in Denmark. But it soon spread to rural water supply, where farmers also found it was better to share their water supply rather than competing for the resource. At the present time, we have still around 2,000 rural water supply companies operated privately by cooperatives and very few public companies. So the scale at an average of 200 households per water company, but ranging from 10 to more than 1,000 households. I'm going to make a few steps into the groundwater value chain. We call it circular groundwater economy. And one back in 1925 about data management, and then move up to the after the wartime in Europe, 1945, onto the year 2000 and up to 2010. In 1925, we actually started recording all information we had from groundwater wells. And this was a physical archive where I was sitting myself in 1968 when I was a student employee at the Geological Survey, and also took part in designing And this was then digitized. The first digitization was one of my fellow students who started the digitization of the well record archive in 1972. After the war, we had the real emergence of new technologies. I'm sure that most of you know Grundfos, who has been in South Africa since 2005. Fewer of you may know the AVK, that's a funny name, but they have also been in South Africa even from 1991, and they produce valves of all sizes, and of course, very important for water. The 2000 event was the EU Water Framework Directive, which demanded all EU member states to map their groundwater resources. And in Denmark, this led to development of SkyTem, a helicopter-borne geophysical investigation of the entire Denmark. As you can see on the right, these are our groundwater aquifers that are significant for future drinking water production and therefore need protection. Denmark is a small country. We are only 40,000 square kilometers. So it also means that life is very easy in Denmark. It is easy to cover the entire Denmark. But we also took this technology abroad, and around 2000, just after 2000, it was used to map the Okavango Delta and the Kavango River area in order to find groundwater resources, freshwater resources that could be used for tourism development. And I'm sure that some of you will have been a part of this investigation. It was carried out by my former company, COWI. And this has now been taken down to the ground with the so-called TTEM also, and being run across the land, as you can see, by a sledge towing and a four-wheel drive towing the instrument and identifying where there are potential groundwater resources. In this case, it would be all the high resistivity layers, which have low transmissivity. It is carried out by Aarhus University of Denmark and has now been split out into an independent company. It has been applied in Tanzania for mapping or identifying water resources for refugee camps, some very large refugee camps up to 200,000 people, but also the surrounding villages. And it is, and it's of course the excellent way to identify, to locate borehole sites. And in 2020, this year, it has been also been run in South Africa at 10 locations, and of course just outside the Bloemfontein. And it's funded by the Paul U. Jensen Foundation. And if you think that's a funny name, then it's actually the holding company of Grundfos. So they have a very good interest in identifying borehole sites where their groundwater pumps can be used. The last step forward has been since 2010, we have developed Blue Control, which is an easy operating system, monitoring and operating system for small water companies or water treatment plants. And it can be operated from simply a mobile phone or from a tablet, and or you could operate remotely from a major water company. So you don't need the resources in each little water supply company. And this is the screen that you can see, you will be able to see on your mobile phone or tablet. And you can go in and you can regulate everything from the abstraction of groundwater through the filter process to the pumping and distribution. And it will also collect all the information for reporting to government every year, as we must do in Denmark. This system opens up for some new opportunities also in Africa because of the development of the mobile networks that I have seen in Africa in 2006. You were actually more advanced than we were in Denmark. It gives the opportunity, as I said, for central unit, well-educated, well-equipped central unit to monitor and operate small water companies in the vicinity, in villages around the small town. This could be a modernization of standposts, as the system is, this is the system operating in Tanzania, the small treatment plant to take out the worst part of, to check the worst part of water quality, distribute a storage tank, and the distribution system to standposts where actually water is being paid for, so that we have ensure a good sustainability. And I was very impressed with the previous presentation where we saw that social issues actually are one of the biggest obstacles to rural water supply in Africa. This is how it could look like. This is an example that we developed for China, a new modern Danish water treatment plant with small satellites located in villages around it. So the last question is really, is this affordable? And Denmark has the highest water price in the world, which is somewhat embarrassing, but if you look closer into it, you will see it comprises both the water supply and the wastewater treatment and huge amounts of taxes. But even if we have the highest water price in the world, we probably also have some very high incomes. So it's only on average 1 to 1.5% of average household income, which is much less than you see in many nations. So to finish off, then this is the water cost of supplying water. And you will see about half in Denmark is the investment, 20% is production, and 20% is distribution, and then a little administration. This is my own water company, which serves around 700 people. And the production cost ends up at a very, very low number. And to put this into perspective, this is the comparative cost of safe drinking water taken from China, where people have very low trust in the public water supply. So they buy bottled water at a huge cost. And you can see that what we do in Denmark is we supply water at 1% of the cost of bottled water. So to me, the question is not whether we can afford to deliver safe domestic water, but whether we can afford not to do. And we should take into account that consumers, including the poor, are willing to pay more than governments typically are willing to charge because they benefit the most. And this, in my opinion, advocates for a community-based water supply. Thank you, and hopefully see some of you in 2021.
Thank you very much, Lars, for once again another wonderful presentation, giving us a perspective of how Denmark is actually managing and monitoring the groundwater resources, the technologies thereof. One can indicate that even in the kingdom, we're using some of these Grandforce products, and we're just trying to check their versatility in as far as even using solar power to actually pump the resource for use by communities. Thank you very much for that. And we still note that the chat box is still open for all participants. If you have questions or issues, you just post them there. Then at the end of this session, we are then going to request the panelists to give the responses to the different questions. Moving forward, may we then take this opportunity to invite the next presentation, which is reviewing the assessment of the impact of global change on groundwater dependent ecosystems in reference to the Tulikaru transboundary aquifer. This is then going to be our next presentation. I seem to have missed the presenter, but I believe that the presenter is available to lead us through this presentation. And who is that?
Kwazi Majola.
Oh, Babe Majola. Mr. Majola, yes. May we then actually give you the floor, sir, to take us through your wonderful presentation, I presume. Thank you. The floor is yours.
Okay. Can you see my screen?
For now, we can see you. Yes. Yes, continue, sir.
Yes, we can. We can. Oh, okay. Thank you very much, Chair. I'm presenting on the assessment of impact of global changes on groundwater dependent ecosystems in reference to the Tulikaru. This is in preparation for my PhD studies, which I'm doing with the University of the Western Cape. under the supervision of Professor Yongshin Shu and Dr. Tawozani Kanyerere. So this is going to be the outline of my presentation, which I'm not going to waste time on. So the aim of this review was to just collect the existing knowledge regarding the assessment of impacts of global changes on groundwater-dependent ecosystems. We also want to do this in transboundary aquifer settings. And then we are looking at the methods that are used, their applicability, and their reliability of their outputs. So the reason for this kind of study to be initialized was because the groundwater and its supported ecosystems respond to external changes, but we do not, the nature of that response is still under-researched and the long-term variability is not well understood. A lot of studies have been done which have assessed the impact of climate change on groundwater resources, but have not mainly go beyond to include or to incorporate the groundwater-dependent ecosystems, which from now on I'll be referring to them as GDEs. In the Tuli Karoo specifically, the studies have been done as well, and it was clear that there might be cross-border negative impacts because this is a shared aquifer between Botswana, South Africa, and Zimbabwe. So groundwater and surface water interactions should be understood for that reason. There's generally a lack of standardized and regular repeated data, which means in essence, there's no monitoring of the state of the GDEs in this aquifer and generally in the world. And because of that, eco-hydrogeological processes, the nature and extent of this GDEs is widely unknown. So it becomes difficult to include them in the integrated resource management of groundwater. Just as introduction, the definition of GDEs is there's been a lot of definitions from a long time ago to present, but in essence, that those are the ecosystems that depend on groundwater, such that if they do not access groundwater the right quantity and the right quality and at the right time, they will be negatively impacted. We know that some of them depend on groundwater for the whole year, or they might be dependent seasonally, or it could just be temporal. So the timing is also important. Again, there's classification, which is, they are divided into directly dependent ecosystems and the indirectly dependent. A few examples for directly dependent would be the discharge into the rivers to create the base flow, or the contribution of groundwater to base flow, especially during the dry conditions or dry seasons. We have springs and wetlands as well, and the in-aquifer in the caves, there's also life there. And then the indirectly dependent, it would be the directly dependent lifting the water normally during the day and then releasing it to the shallow GDEs at night, a process known as hydraulic lift. And to characterize this GDEs, from the literature, it's clear that a lot of the studies were done elsewhere and not in the Southern Africa, where we have subtropical and semi-arid. We have a semi-arid region. There's not a lot of studies concerning the GDEs here. And a lot of methods like GIS tools, you have spatial data, remote sensing, we have isotopes analysis, and we have a lot of methods that have been developed in different countries or different regions, including the modeling, which are trying to characterize these methods. From these characterization methods, the general conclusion is that the characterization of GDEs, eco-hydrology to be precise, we need frameworks that are able to provide quantitative tools to investigate the interactions between shallow aquifers and soil moisture. Most of the times, the GDEs are dependent on shallow aquifers, although through hydraulic interconnections, probably there can be that dependence on the deeper aquifers. And of course, the main tool would be a good starting point would have a conceptual model to incorporate which would incorporate the GDEs. We have a lot of conceptual models, but again, they have not incorporated GDEs. And this is a challenge in the scientific field. As I said, the impacts of global change. We know there's various aspects of global change, but in this case, I would like to focus on the abstraction, groundwater abstraction and the climate change, because we know that abstraction disrupts the hydrological cycle and alters the variability of groundwater levels. As they decline as well, the groundwater quality can deteriorate. Also, the timing of accessibility to the GDEs of that water, as I said earlier. And obviously, the shallow aquifers are mostly susceptible to this overexploitation. On the climate change aspect, temperature and precipitation anomalies, we've seen previous studies, they project that Southern Africa would have hotter and drier climate conditions. And therefore, that means we're going to have declining groundwater levels. And that means we have to manage those adequately. Different methods have been used in trying to assess this climate change impact. As I said, though, it's mostly the impact on groundwater resources, not going beyond to include GDEs. Mainly the global and regional circulation models as simulated precipitation rates are used to predict inflow into the calibrated groundwater models. And these models, the outputs from these regional models are having some uncertainties, and these can be due to many reasons, different reasons. Some of them could be the climate model that you choose to use, the data quality, which is a very big issue with the Southern Africa or the Limpopo Basin. And then the downscaling methods which you apply when you're taking from the global model to a local scale model. And of course, the boundary uncertainties. So a big recommendation, especially for arid regions and where the data is not adequate, the coupled surface groundwater modeling approach is recommended. And from all these studies, the main thing is that an integrated model or an integrated kind of a model or a combination of models. Mainly the recommendation is to use a combination of models in order to address these uncertainties. And of course, use the appropriate downscaling processes so that they are suitable for the study area. The Tuli Karoo transboundary aquifer study specifically, I thought I should do this in a transboundary aquifer because from some time ago, previous studies again have called for the assessment of groundwater, GDEs, surface water interaction before there can be establishment of the using of the resource between the sharing countries. Also, the recent study of 2013 has called for frameworks for managing the already stressed shared groundwater resources and associated ecosystems. So for this study, my objectives is the first is to delineate and map the GDEs where they exist, and therefore understand the groundwater, how groundwater is maintaining the GDEs in the area. So the first objective is to develop a conceptual model which will explain the groundwater characterization which will explain the groundwater processes that characterize the DGEs in the transboundary aquifer. Also from that, because the main aim is to do the assessment of impacts of global changes, or let me say climate change, we'll apply the appropriate methods to test the resilience of GDEs to these impacts. And then the output will be a monitoring, evaluating, reporting framework for GDEs which are applicable in a transboundary aquifer setup, or it can also be any other aquifer probably as well. So this study in brief, the area is 12,000 kilometers squared, shared between Botswana, South Africa, and Zimbabwe, with the dominant land uses, including the agriculture and then mining. Some mines are outside of the study area, but they draw their water from the study area. And then you have the conservation areas as well. From some data that we got during in the study area, it shows that the temperatures are increasing gradually. The long-term rainfall data shows the fluctuations. Now, there are places where they are very dry. There are periods where we have very dry conditions and very wet conditions. These will be useful when we do the classifications or the analysis of remote sensing images, when we try to see what kind of vegetation specifically would survive during these dry times. That's the evergreens, which will show us that probably they are the potential GDEs. Also, the monthly distribution, it shows that between April and September, there's dry conditions, and from October to March, those are the wet condition periods. And I just selected 1 point gauging station at the Bait Bridge, which is downstream of the study area. And we see a few, the flow rates. With the base flow index around 0.24, this could imply that the groundwater contribution into the base flow is about 24%. But the other gauging stations upstream of this, it's not a lot of gauging stations we got, but some of them are less than 24%, are showing less than 24% contribution. The groundwater levels are following the ground surface elevation. There's a good correlation in those. I would say mainly this is probably alluvial aquifer in the area. Briefly on geology and hydrogeology, this area is a part of the Karoo supergroup, which is characterized by a series of mudstone, siltstone, and sandstone, and then overlain by the sandstones. I can just show you in this map. The sandstones, which is the secondary aquifer, which is regarded as the main aquifer in the area. And then that sandstone is overlain by the basalt, which is a trough-shaped trending northeast, but dipping towards the center of the study area of the aquifer. And then towards the edges, the basalt is thick towards the center of the area, and towards the edges, it thins outside, towards the edges of the study area. On top of that, it's overlain by alluvial aquifer, which is a primary aquifer, and most of the abstraction is from this alluvial aquifer, which I did not show on this map, on this small graph. This is just a small schematic to show the possible movement of groundwater in this sandstone, and it's discharging towards the edges of the main aquifer, which is the sandstone aquifer. Excuse me. The area is characterized by when it comes to vegetation, the potential DGEs, they are mainly dominated by the savanna biome, and the vegetation types, the Limpopo Ridge bushveld and the Musina Mubane bushveld. And we know that the savannas are known for sometimes having very deep tap roots, which could reach the deeper aquifers as well. There was a few studies that were done on the vegetation. One was in the Botswana part of the study, where they used remote sensing to see the evergreens, and then the probability that, which means there's a probability or possibility that they depend on groundwater. These are the areas that will be targeted for isotope analysis study going forward. And in the South African side, in Mapungubwe, there's a study that was done in 2014 which confirmed that some vegetation there, the nyalas, the fever trees are actually using groundwater, mainly from the alluvial. Although it also confirmed that these trees or vegetation types are among the high mortality, among those with high mortality rate. The reasons could be obstruction because there are mines and irrigation, or it could be climate change that still has to be determined. Also, again, in Mapungubwe, there was mapping of wetlands, which are, some of them are seasonal and the permanent ones. We just have to do the isotopic studies there to see if these are actually groundwater dependent. And there are springs as well in the area, and pans. The sampling which will cover all those when the time comes. If it wasn't for COVID-19, this part of the isotopic analysis part would probably have been done, but the study had to take a break for a moment. So as I said, the next part, yes.
Majola, yes, we may request that you just try to wind up now.
Okay, this is my
how
last
many
point.
slides you have left.
This is my last point.
Yes, yes, sir.
Yes, I'm done almost.
Thank you.
Okay, so the next step is to do the conceptual model as I indicated, and then we'll use that model going forward to do the assessments of impacts by the climate change and obstructions. Thank you.
Thank you. Thank you very much, Mr. Madola, for that very informative work that we are actually doing, trying to secure and actually guide us on how we are supposed to protect our ecosystems, especially those dependent on groundwater recharge. We are still advising attendees to post questions on the question and answer slot. In the case that one fails, you can also use the chat box to raise your questions. Maybe at this point, we are then going to allow the last presenter, who is starting at 12:35, who goes by the name of Shupala and others. May we at this point invite our presentation, which is going to be looking at an isotopic study of the groundwater at the waterback in Namibia. I believe our next presenter is available. I can see he's trying to load the presentation. There goes the presentation. The floor is yours. Please continue.
Good afternoon, everyone. I'm going to take you through an isotopic study of groundwater at Waterville that I carried out with Heike Vange from the University of Namibia. Okay, it's a clear objective of water resources management in Namibia, and I believe in the entire world, to use the groundwater resources on a sustainable basis without causing any environmental damage. That's according to Crystal and Strackmeyer, 2011. And precipitation is the main input in the hydrologic cycle. Okay, precipitation is the main input in the hydrologic cycle, and therefore it plays a big role in groundwater recharge, which eventually plays a role in the sustainability of the aquifer. And if one want to understand then the isotopic fingerprints of groundwater, it's always good to first start with precipitation. So then in this study, we then looked at both the isotopic composition of precipitation, rainwater, and groundwater. And with these isotopic compositions, we were also able to determine some groundwater recharge rates. Just to show you, where our study area is. Our study area is located in an area which is receiving about 450 millimeters per annum. And it's covered by the Kalahari sediments that are of less than 10 meters thick. And they overlay the Echo Formation, which is a sandstone of the Karoo group in the western part of the study area. So we then have two aquifers in the study area, where we have the darker part, which is the porous alluvial aquifer with moderate groundwater potential. And then we have the sandstone, which is a hard rock body, which is having a low to moderate potential, but locally it's having a high groundwater potential due to fractures and faults that are found in this sandstone. So then our study only looked at the sandstone, because most of our sampling points are in the sandstone, where we sampled the springs, the contact springs, and the boreholes in the study area. Okay, so we sampled rain samples as rain events from October 2017 to April 2018, and we collected a total of 28 rain events from the rain gauge. And for the groundwater, we sampled before the rainy season, during the rainy season, and after the rainy season. That was between 2016 to 2017, and a total of 25 groundwater samples were collected from the boreholes and springs in the sandstone. And what we have here is a picture of collecting water samples, groundwater samples from one of the springs in the study area. And then our analysis were done then at the University of Namibia using the Los Gatos spectrometer. Then for the precipitation data, we plotted them. We did a dual plot of deuterium versus oxygen 18, and we were able to derive a local meteoric water line. So most of the samples are plotting on the global meteoric water line, or even below. And the ones that are plotting below the meteoric water line, they are indicating an evaporation. It could be that they were not collected instantly from the rain gauge, and therefore are affected, or the signature changed due to evaporation. And what we are seeing, that most of these samples that are enriched are samples where the precipitation or the rainfall amount is below 5 millimeters. Then for the groundwater data, since we collected during rainy season, before rainy season and after rainy season, we found out that most of the groundwater samples are plotting on the local meteoric water line or on the global meteoric water line, which is indicating a fast infiltration of rainwater with the absence of evaporation. And what we are seeing there also is that most of the rain events that are leading to groundwater recharge are the ones that are more than 5 millimeter. Yeah, because this is the weight rain mean, the weighted rain mean, which means that most of the rain samples or rain events that we have collected above that are not contributing to groundwater recharge. And by saying that there's a fast infiltration of rainwater with the absence of evaporation, this could be through the fractures and faults that we are finding in the sandstone, since it's faulted. Yeah? It's sedimentary faulted. It's documented. And then for the groundwater recharge estimation, we used a method which was originally used by Allison in 1984, and then it was modified by Clark and Fritz in 1997, which is a parallel shift method, which is giving the recharge rates. And these are the two equations that we used. So we had to determine then the parallel shift for oxygen 18 and the parallel shift for deuterium. And then with that, the shift, we plugged them into the equation and we got values. Yeah. So for the rainy season, we got values that are ranging from 16 millimeter per year to 21.3 millimeters per year. Then we did the same for the after rainy season, and we got recharge rates that are ranging from 26.4 to 215.1 millimeter per annum. And this is giving us a very wide range. And it's known for this method to give crude values. But if we are to exclude these two crude values, then we get an average groundwater recharge of 24.3 millimeters per year. And then if we include these values, then we get a groundwater recharge of 61.7. So what we have observed is that we have higher recharge rates after rainy season as compared to during rainy season. And the variation in recharge rates probably could arise from the anisotropic and inhomogeneous of the fractured or faulted sandstone. Then we compared these rates to other rates that have been estimated in the study area. One of them is what we did using the chloride balance method, where we got an average of about 40 millimeters per year. But then a study was also done in the same basin, but not specifically at Waterbell by Cools, who used the water balance model and obtained recharge values that are in 20s, in 20s millimeters per year. So to conclude, this study is that we were able to determine the local meteoric water line of the study area, and this can be used for further isotopic studies. And also that the high recharge rates that we have observed are related to the absence of evaporation as indicated by the isotopic ratios that are plotting on the global meteoric water line or on the local meteoric water line. And this is due to preferential flow paths. And also the identified groundwater recharge rates and recharge mechanisms that are revealed by these isotopic compositions can provide a useful information for groundwater management, especially determining the sustainable yield for the aquifer in that area. I thank you.
Thank you very much, Shupala, for the very informative presentation on the work that has been done in Namibia on the use of isotopes to actually do groundwater or to assess groundwater recharge rates. We take it that issues that may arise from these presentations remain available on the chat box and the question and answer slot. I've noted that some of the questions raised have been attended to by the different presenters or panelists. At this point, we are now at the question and answer session, to which we are requesting for any outstanding issues on the 5 presentations made. We can then entertain them at this point. In the case you have not been adequately attended to on the responses given to the question and answer box or the chat box. At the same time, may I take this opportunity to request that we all actually switch to our video modes for us to be able to take a photo session. With technology, things can always be possible. If we can all switch on to our video modes so that whoever is going to be taking this very, very nice picture of ours is able to do so. I can see people are coming in. I'm not too sure how much time are we going to allow. We're going to allow for people to switch on to their video modes. But I believe Thokozani is going to advise us in the case there's going to be people still outstanding with their videos. Mr. Dlamini, can you guide this one?
Thank you, Chair. I don't know if these are the only panelists that we have. I thought if we still even have panelists from the morning, we can just combine them and take one group if they're still here. Because in the morning, when we completed the first session in the morning, we did not take a group picture. So if the panelists that were presenting in the morning, they're still here, they can still switch to their videos as well. Then we can take the picture.
Yes, the invitation is for all of us present. I think there is 76 people here, or panelists is 31, and attendees is 44. If we can switch on our videos, and Mr. Dlamini will do the magic. You just indicate, Mr. Dlamini, for us to give you a good pause. Otherwise, if you were to take with Shupala looking the other way.
But yeah. I'm not seeing the rest of the panelists. I don't know if maybe because it's only the panelists that could be able to take the picture, not the attendees. So we thought maybe all the panelists that were presenting since this morning, if they're still available, can they switch their video on, please?
Of the 35, how many do you see on video now?
I only see 3. I only see Ross, I see Gwazi, I see Shupala. Those are the only 3 that I'm seeing.
I'm seeing 14 on my side.
Oh, you're seeing 14 on your side. Okay.
Yes. There are 2 pages. You might have to scroll.
Oh, okay, okay. So now if you're seeing like 14 or 15, I think maybe you can do the magic. It's Niza that is taking the picture. Niza, you can take the picture and tell us when you're done.
Okay, when everybody's ready, please smile. Taking the picture on 1, 2, 3. Thank you very much.
Thank you, Mr. Damini and Naida, for taking the picture. This slot is for questions and answers. Any outstanding issues? There was an issue that was raised, I believe it was to Diana, on the publication of the material that she was presenting in the morning on the conventional methods, tillage methods, and the non-conventional. If she's around, I believe she can react to that. But if she's gone now, we can tackle that one. She gave a response. Diana, are you still around?
Yes, I am. I'd indicated that we haven't published as yet, and I'd given an email address. For those who are interested, we can include you on the CFIS list of people who usually receive quarterly updates of what we are doing. And in there, we'll include all the hydrogeology work as we go along. So whenever we publish, we'll indicate in there, and all the other information that comes in as we continue with the project on the hydrogeology component will also be in there. So I'd given the email in the chat response, but it's also cfas@bgs.ac.uk, and CFAS with the CEPHAS @bgs.ac.uk.
Thank you very much for that response. And I saw that there was a question also given to Zahid on the use of machine language or machine systems for other parts of the region, to which it was indicated maybe that this is possible. Zahid, are you still around?
Yes, Chair. Can you hear me?
Yes, yes, we can hear you.
Yes, I am around. I did answer the question, but I'll just repeat it. So yes, it is possible if you've got the data and the quality of the data and the quantity of the data is good enough. You can certainly develop models for different aquifers. We did actually an experiment in the Shire Valley aquifer to replicate the model in that particular aquifer, which is the Google aquifer. And unfortunately, the level of data in that aquifer wasn't good enough to apply our particular design for the model. In that case, we could only really model a single borehole in the aquifer, and it didn't really come out quite well. The predictions were very poor, simply because we didn't have the data available to train the models effectively.
Mm-hmm.
If you've got the data, it can work.
Thank you, Zahid. And there is one comment that came, I believe this is Portuguese, from Antonio. Can we have the translators help us on that? It came at 12:04. Do we have the Portuguese translator to take us through that one? It's written in Portuguese, if I'm not mistaken, from Antonio. James.
Yeah, yes, Chair.
I noted that you actually are very familiar with this language. Did you see that message?
I'm trying to locate it.
It's before Brighton, who came in on the machine.
In the chat.
Yeah, in the chat box.
It's eluding me. So so it's someone who was saying that the panelists and participants would like to place questions in the chat box, but the panelists should respond or something. They are not responding. I guess it was more of a comment to say that to the translators that there are questions being posted in the chat box, but they are not being responded to. I suppose that's what you are doing, Chair.
Thank you very much. And we are also requested to complete our registration for the session today and then indicate the language which we are requesting to use even on our special sessions. I see no further questions or issues on the chat box or the question and answer slot. And that would then indicate that we've come to the end of our session, which is the second session of this day. And with that, may I take this opportunity to thank all our panelists for the wonderful presentations given, very informative, and also thank you, our attendees and participants, for your active engagement on the issues or the papers presented. And with that, may I then close this session and give this opportunity or the platform to our chair, the main chair, to guide us on how we move forward from here. Thank you.
Okay, thank you very much, Trevor, and all the speakers. We really appreciate your efforts to stick to the times. I see now we are just out of our planned schedule by 3 minutes, which I think we are still doing very well. So in the meantime, we are going to break for lunch for about 30 minutes. And it means we are going to come back here by 13:30. But let me just give you the 2 minutes and say 13:35, because I see now it's around 13:04. And then we are going to get into the special session, which will be talking about the knowledge sharing workshop for focal points. So let's try to come back exactly at 13:35. Thank you.
Thank you, Fezisani. Welcome back, colleagues, to this special session that is being jointly organized by the UNESCO IHP through the regional office in Harare. I will try and get us going by means of a very short presentation that will mainly be focused on raising some pointers, and the other colleagues on the panel will then take up the issues in more detail, and hopefully that will trigger the discussions that we are hoping to have in this session. So basically, I'll look at the history and significance of transboundary aquifers in Africa from a continental perspective. Then I'll zero into Southern Africa transboundary aquifers status and current work. Then I'll look at the, what is happening in terms of transboundary aquifer management in the SADC region. Then lastly, I'll look at briefly summarize what this session is all about and hand over to the other presenters. So given the advent of climate change and increasing population, the significance of transboundary aquifers has come to the forefront of the discourse of groundwater management, especially between riparian states in the African continent. And what has also been noted through previous studies is that most TBAs occur in high storage and high yielding aquifers, making them a significant groundwater resource for the continent. And in terms of studies around the transboundary aquifers. Around 2000, there was a significant growth in the systematic assessment and governance of transboundary aquifer, following concerns by member states of UNESCO and the World Meteorological Organization. To date, about 72 transboundary aquifers have been mapped in Africa, and the significance of this aquifer is probably underlined by that 42% of the continental area of Africa is underlined by these transboundary aquifers, with about 33% of the population living in these transboundary aquifers. What probably makes them very important or more important is that they are usually found in the arid areas of the continent, where probably they are the main source of a stable water resource for the communities. And but still, despite the importance and significance of these transboundary aquifers, only 11 transboundary aquifers have been studied at the continental level, and a small number of about 7 are subject to some specific agreements on joint research, monitoring, or governance. Looking at Southern Africa, of the 72 transboundary aquifers that have been mapped in Africa, about 30 transboundary aquifers are located in the Southern African region. What we have on the left is the transboundary aquifers that have been mapped in the Southern Africa. The green ones represent aquifers where no work has been done. What is colored is where some work has been done. So plus or minus 4 aquifers have been studied in detail. What we have in an orangish color is marked AF5 is the Stambridge transboundary aquifer that will mainly focus our discussions on in this special session. What we have on the right is just a progression of the numbers of transboundary aquifers that have been mapped on the African continent, and the last line on that table is Southern African countries, and the last studies shows about 30 or so transboundary aquifers have been identified in the Southern African region. And the take-home point here is that most of these transboundary aquifers in Africa, about out of the 70%, a good percentage is found in the Southern Africa region, making them an important resource for consideration. So what has been happening around transboundary aquifers in the SADC region? And there's been a significant advance, relatively advanced approaches or work being done in the region in transboundary aquifer management. And notably, you have this work being done in the context of the river basin organizations. You have where significant work has been taking place or is taking place. You have the Orange Senku River Commission, the Limpopo River Commission, the Okavango River Commission. And in the Orasecom, which will probably be our focus of discussion today, we have the Orasecom Secretariat being the first to establish a groundwater hydrology.
Secretariat of Orasecom?
The Groundwater Hydrology Committee, which was established in 2007 to facilitate transboundary aquifer management in the basin. And also maybe specifically, the agreement is one of the only river basin agreement that makes specific or explicit reference to hydrological data being or the need to share, or the obligation for member states to exchange and share hydrogeological data. So going forward, the transboundary aquifer management principles were piloted in SADC, focusing on the Stambridge transboundary aquifer system through a case study, which was implemented by UNESCO IHP under the GEGRETA project, which is the governance for groundwater resources in transboundary aquifers. So briefly, the GEGRETA project is undertaken in 3 regions that are shown on a global scale: Southern Africa, Europe, and Southern America. And in the Southern Africa region, it is being piloted in the STARS, which is the Stambridge transboundary aquifer. And the importance of this resource is that it's probably the only permanent and dependable water source in the area. So coming to this special session, presenters coming after me will delve into this. The STARS project is currently in phase 3, And phase one mainly focused on a science-based understanding of groundwater resources. And for the Stamford transboundary aquifer, detailed hydrogeological investigations were done, and also a numerical groundwater model developed to form a basis for the understanding and management of the transboundary aquifer. Phase two looked at cross-border dialogue, and which was enhanced by development of management tools. So we'll have a presentation from UNESCO IHP that talks about the phase three of this project. And as I've mentioned earlier on, the STARS is probably one of the pilot transboundary aquifer management investigation that was piloted in the Southern African region. We realized there are a lot of opportunities to learn lessons from this project and also to try and replicate these experiences in the SADC region. So what you'll see in this session is you have the presentations by Prof. Kenabatho, who go into the details of Gigreta phase 1 and Gigreta phase 2. UNESCO IHP will talk about Gigreta phase 3. Then we'll have two panel discussions. The first panel discussion, which is going to be moderated by James Sauramba, will look at the discussion with the national coordinators and also try to extract some lessons learned and what are the things to correct going forward. We'll also have another panel discussion that looks at the broader picture, taking into consideration other stakeholders, the SADC Secretariat, River Basin organizations, international cooperating partners, and see how those lessons can be implemented going forward, what we have learned so far from the STARS transboundary aquifer. And then we'll close with a conclusion in the workshop by James Sauramba. So colleagues, that was my quick presentation on what we are going to do. I hope I have given you an insight on what this discussion is all about. I'm trying to multitask here as the chairperson and also transitioning from this presentation. You will see the next presenter here is Professor Kenabatho, who will talk about an overview of the Gigreta phase 1 and phase 2. Over to you, Professor Kenabatho. Thank you.
Thank you so much, colleagues. Good afternoon. And thank you, Brighton, for such a good introductory remarks to this session. I think you've saved me some time on some of my slides, especially on the backgrounds about the TBAs in Africa and Southern Africa. I will present an overview of the Gigreta project, mainly focusing on the Stamford and phase 1 and 2, highlighting the main findings and achievements to date. Just for those who want to contact me afterwards, that is my email there on the screen as well. Just to be sure that we're on the same page, is my second screen showing?
Yes, Prof, go ahead.
All right, thank you so much. The Gigreta project, I think Brighton has said it, it is governance of groundwater resources in transboundary aquifers. This project is funded by the Swiss Agency for Development and Cooperation, SADC, and implemented by UNESCO, IHP, as well as the IGREC as well, which unfortunately I didn't put it there, but it's also has been part and parcel of this work from the start. The main objective overall is to foster water cooperation for the governance of groundwater resources in the 3 TBAs that Brighton talked about. But for this presentation, I will focus on the Stamford, which we now know as the STARS. And on the right, there is a publication that colleagues can have a look at, which has most of the information that may not be provided in this presentation. It's a work that has been ongoing for the last 7 years or so. And so you can imagine putting things together for this many years. So I just chose to highlight what I probably could be important for this session, and others could be addressed in the question session. In terms of the chronology, it started in 2013 to 2015, which was phase one, focusing on in-depth assessment of the stars, the hydrogeology, the socio-economic and environmental components, as well as the legal and institutional and gender components. So that has been really a multidisciplinary endeavor from the start. Phase two, between 2016 and 2018, focused on capacity building modules on groundwater modeling, legal and institutional and gender issues, with the initiative to start the development of the STARS numerical model, which I think some of you who attended UNESCO online course a few weeks ago or 2 weeks ago was presentation on the numerical model. That was also accompanied by setting the baseline for institutionalizing cooperation over the stars, which will be the main emphasis for this presentation as it deals with water governance. Okay. In terms of the project approach, I think from the slide, there's a transition from the in-depth transboundary multidisciplinary assessment, framework for dialogue on transboundary aquifer management, mainly by the STARS family. The most important thing was focusing on trust building between the three countries that are sharing the aquifer, development of the stakeholder mapping approaches and identifying issues through capacity building that was really underpinned by the water diplomacy of UNESCO. I think maybe Dr. Alice Aureli will talk a little bit about this in the next presentation. Consensus building, I must say that that was really truly a consultative process, as you will see from my other slides. And then on the left side there, you've got the capacity building modules that I mentioned earlier on modeling issues in all the three countries, as well as other topics such as international and domestic water law and gender issues. That led to the bottom part that you see there, the science that led to achievements of the multi-country cooperation mechanism, which is actually a cooperation establishment for the management of the transboundary aquifer beyond the project life. And then the other thing that was very important was the strengthening of cross-border dialogue and cooperation and facilitation of governance reforms. Even more importantly was awareness raising on transboundary groundwater issues, not only in Southern Africa, but also in the whole region as well. In the next slide, I just present a little bit about the stars, which entirely lies within the Orange and Two River Basin. And you might also have heard from Brighton that RASOCOM is one of the old river basin organization in Southern Africa, established in 2000, led by the governments of Lesotho, Namibia, South Africa, and Botswana, mainly to promote equitable and sustainable development and management of the water resources of the Orange and Two River Basin. In terms of the area, the stars is about 86,000 square kilometers. Rainfall is quite low, between 150 to 300 millimeter per year. Evaporation very high, estimated at more than double the rainfall, or quadruple the rainfall, sorry, about 2,000 millimeter per year. The population is lightly populated, about 50,000 inhabitants, and the main economic activity is agriculture and livestock, mainly 52% for irrigation, 32% for stock watering, and a little bit for domestic water use. Currently, there are no mining activities in the area, and the human dependency is 100% groundwater use. In terms of the estimation of groundwater abstraction is about 20 million cubic meter, and 70% of that comes from the Stamford area in Namibia. And I'm happy that I don't have to tell you what Stamford means. I can see in the attendance, we've got Bertram from Namibia, whom we have really worked with for the last 7 years or so. So he will at some point tell us what stamp rate means. And that for me, he told me, but he may want to comment later on. The assessment approach, as you can see there, multidisciplinary, as I said. On the right hand is the conceptual framework of the assessment, where it started with data collection from the 3 countries, harmonization and aggregation of different nomenclature in the hydrogeology, and also other components as well, which was not really an easy thing, but it took more than we had thought for. But I think in all the assessment, I think significant amount of time has to be committed to delineation of the aquifer and also harmonization of the nomenclature, as well as the aquifer characterization. So that led to multi-country consultative body, which is the institutionalization of TBA for sustainable management of the TBA resources. That also made use of UNESCO's methodology based on measurable and monitorable indicators that can be easily verified to describe the complex aquifer system in easy to understand and intuitive way. In the next slide, this is really one of the very interesting slides that I want to present, because that actually shows from the onset the high level political representation and involvement in the stars, which we actually believe is one of the positive sides which led to the establishment of the institutionalization of the aquifer. So it was well represented at a deputy permanent secretary level to a higher level, both in Botswana, Namibia, and South Africa, where in South Africa it was at a deputy director general, which was still quite influential. And then there we had the national coordinators that probably you will hear from. In the original one, I think the one for Namibia was later replaced by Ms. Maria Amakali, who is the director of Department of Water Affairs in Namibia. And then my fellow Kwazi from South Africa, as we heard from his presentation earlier on. And then the rest at the bottom there were the national specialists that were dedicated to different components of the assessment, and the regional coordinator, as well as the UNESCO as the project implementing partner. So I thought that really model right from the onset, it provided a political will at the onset. Some of the key achievements that I will highlight here, and are not exhaustive, is that the stars moved towards a better cooperation and improved trust building between the 3 countries from the onset, leading to improved knowledge and recognition of the importance and vulnerability of transboundary groundwater resources. You can imagine agreement on the delineation of the stars that I talked about, which took to about 3 months or so. And then as well as the agreement on the hydrogeological conceptual model, which at the end really bore some fruits to indicate the recharge and discharge areas, the groundwater flow, and the potential pollution risk areas. In the slides that you are at the bottom there are 2 things that I want to show, which one is the different aquifers right from the top Kalahari aquifer, which is more continuous and transboundary, to the 2 deeper aquifers that are the Au and the Nosop, and then the groundwater flow also, which is from the Namibia into Botswana and ultimately to South Africa in that direction. And then other important points to note is that this led to the development of a database of about 6,000 boreholes that was also put in the information management system, courtesy of IGREC at the time, as well as UNESCO, and then preparation of 60 thematic maps, over 60 thematic maps, providing information on groundwater levels, quality, despite some limited information that we had. I am also showing one of the wells that was also discovered in the database, which was struck in 1912 with 110 cubic meter per hour free-flowing artesian characteristics. The information on different aquifers, they differ. When you go to the deeper aquifers, the information becomes limited, as you also may know. Some of the other achievements was the facilitation of governance reforms, focusing on improved livelihoods, economic development, and environmental sustainability. And that also was facilitated by the proposition for a cooperation mechanism at facilitating cooperation for the management of the TBA. Other capacity building programs that I talked about: international water law, water diplomacy, information management system, as well as groundwater modeling in the 3 countries, but also at the entire SADC region, because some of them were open to the SADC region. Some of the other important information is to make a point that the general perception at the moment is that there is no long-term groundwater depletion and pollution in the area. However, the fragility of the system could create conditions of stress in the future. For example, if there is over-exploitation as a result of influx of mining activities and many others. There are also need for measures to prevent potential depletion and pollution problems, as you have realized that there are other problems in groundwater issues within the stump rate. For example, there is need for rehabilitation of leaking wells by introducing and implementing regulations on well construction and by effective well licensing procedures. Need for improvement of water and sanitation, including sewage and wastewater treatment provisions, as well as protection of key recharge zones, particularly in the recharge zones within the stump rate part in the Namibian side, as well as awareness raising and also capacity building issues. This in the slide, I will just pick that an issue to do with uncertainty as a result of lack of information. You can see the cross-section that is there from moving from southwest to northeast from Namibia into Botswana. You can see all the important or the major aquifers there. But when you come into Botswana, you see the question marks there indicating no information or limited information for the Nosop aquifer at the bottom there. And that is also an important point, an entry point should there be need for further investment in terms of filling in the gaps. This also shows that when you go to deeper aquifers, the information becomes very limited, especially the groundwater levels, as well as the water quality parameters for deeper aquifers. For the moving towards the institutionalization, some of the key findings is that no legal instrument that is specific to the management of TBA, both at the regional SADC level and regarding specifically the stars exist. Transboundary groundwater in general is integrated into the revised SADC protocol on shared water courses, but only to the extent that it is hydrologically connected to a surface water course. Groundwater is also integrated in the Orange and Two River Basin Commission, however, only indirectly. Domestic policy, legal and institutional frameworks for groundwater are in place in all the 3 stars countries. The laws of the 3 countries regulate abstraction and potential point source pollution through a permit system. But when it comes to non-point source pollution control, other laws will come in, for example, environmental protection and mining acts, EIA and others. So from the domestic, legal and institutional perspective, it is fair to say that the laws are in place in the 3 countries and they are adequate to deal with the challenges ahead of the aquifer. So strengthening domestic capacities, institutions in implementation and enforcement is necessary to support cooperation for the management of the stars. So in 2017, the stars MCCMO, the cooperation mechanism, was established as a permanent institutionalized cooperation among the 3 countries sharing the stars through the ORASCOM structure. So the STARS cooperation mechanism will generate flow of information or data that will contribute to Orascom's 10-year IWRM plan, specifically for strategic objective 2 under climate change adaptation, and many other important milestones within the Orascom and the 3 countries that share in the aquifer. So this is just a demonstration of the correspondences between Orascom and UNESCO towards the establishment of the institutionalization. So this really, the STARS MCCM is the first operational governance mechanism to be nested in a river basin organization in Orascom in SADC, thus fully capturing the tenets of IWRM as we know it. The objectives of the STARS, in the main one, is to transition from the project-driven cooperation to a permanent institutionalized cooperation among the 3 countries sharing the STARS within the Orascom structure. So in the short term, really, is to continue the joint study and characterization of STARS. As I mentioned earlier on, for example, the ongoing refinement of the numerical model, groundwater model, as well as generation of flow of data to feed the STARS borehole database. And even more importantly, reporting on activities at each meeting of the Groundwater Hydrology Committee of the Orascom. In the long term, the vision is to move from data collection and exchange to joint strategizing, advising the STARS country on management of the aquifer and its resources, which is part of phase 3 that we will hear more about from Dr. Aureli. This is the structure of Orascom, right from the secretariat to the technical teams, and this one falls within the water resources quality working group, under which you've got the MCCM in the Groundwater Hydrology Committee. So one key issue is that for the MCCM, you see there are 3 focal points from the 3 countries and multidisciplinary, as I mentioned, both the hydrogeology, the legal, the gender, and also the environment. So those 3 will also be key and supported by invited members such as the SADC-GMI, who brings in now the expertise at a regional level. Then the takeaway messages as I conclude is that groundwater is not only about science, it is also about policy and legal frameworks. So involvement of and consultation with high-level political or decision makers throughout the TBA process is very important for buy-in at an early stage. Institutionalization of cooperation is key for sound groundwater governance at regional levels. One more important thing is that RBOs can play a key role to promote groundwater-based climate adaptation. We have seen that many RBOs already have climate adaptation plans. However, many of these have usually considered only surface water, and RBOs really can be an entry point for groundwater management and also towards setting up managed aquifer recharge schemes to contribute to climate adaptation. And lastly, Chair, is just to say, let's not forget the universities and training institutes, so that this needs to be strengthened to ensure sustainability, in particular on topics such as groundwater governance, groundwater modeling, and so on and so forth. So at the end, there is really no one-size-fits-all solution for institutionalization of cooperation over TBAs. As I conclude, in the last 5 to 7 years, the SADC region promoted and implemented other TBA assessments with a view to establish groundwater governance. We have seen other TBAs under assessment, the Ramotswa, the Shire TBA, the Tuli Karoo, and lately the Eastern Kalahari Karoo TBA. So Chair, I think that's where I can stop for now. Participants can look at the Orascom website for further information. So that slide was taken at one of the Stamford area. And I thank you and have a good day. Thank you, Chair.
Thank you, Prof. Kenabatho, for this very elaborate presentation. Colleagues, I can see comments are coming into the chat box. we'll find a slot to come back to the comments and discuss them as we progress with the panel discussion. Next, what you have on our program is Dr. Alice Aurier, who was supposed to present the Greater Phase 3 project. Instead, we have Koen Verbist from UNESCO IHP Regional Office in Harare. Koen will present on the Phase 3 the Greater project. Over to you, Koen, and welcome. Thank you.
Thank you very much, Brighton, and thanks for welcome. I have the difficult task to replace Alice, and I'm sure very many of you are disappointed by that, but at least I will try my best to do as good as I can. So I'll just share the presentation that we had foreseen to give. Hopefully you can see the screen by now. If so, I should be able to present to you. Can you just check if everything's fine from your end?
Yeah.
Okay. So I was asked to replace Alice to give you a quick overview of Greta Phase 3, and I looked at the attendance group, and I think many of you have been already quite engaged in some of our activities. So I expect that I can go through it quite quickly, and that we can leave enough space for discussion and further action in this session. So as you know, the Greta, or Governance of Groundwater Resource in Transboundary Aquifer Project Phase 3 started 2019, but actually did start activities in 2020. Just as a background, what we took for this project is that the fact that transboundary aquifers are continuing and expanding, but institutional effectiveness is still impaired because a lot of focus is still on surface water, and that still needs to be readdressed. Additionally, of course, Sustainable Development Goal number 6 is expected to provide a major target for the efforts of practitioners dealing with transboundary waters, and there's also specific action on aquifers. So joint governance of aquifers arises through trust building, and I think Pete also mentioned that in his presentation. And that takes time to evolve and to materialize. So actually the approach that was taken so far by Greta was to go through a comprehensive capacity building exercise, including joint training, joint field services, and joint case studies to make sure that trust is built over time. So I think I don't have to go in detail on Phase 1 and 2 since Pete already elaborated quite well on those, but just to give you the background, the Phase 1 was really focused about the science-based understanding of groundwater resources and transboundary aquifers, strengthening technical capacities in the countries sharing aquifers. In Phase 2, a next step was taken where there was an enhanced cross-border dialogue and cooperation, which was, let's say, worked around shared management tools and recommendations for governance reforms. And some of those reforms actually happened already in that second phase or shortly after. So in this third phase, which would say we started this year only, we focus on strengthening regional stability, cooperation, and peace through the establishment of cooperative frameworks for transboundary governance of groundwater. So in this phase of 3 years, we will be aiming to capitalize on the lessons learned in the previous 2 phases. And one of the reasons we're here today is exactly that exercise, to see exactly what we have learned so far and how we can build on those lessons in this third phase. So the project will also focus on local, national, regional, international stakeholders to implement changes and strengthen governance, policy, and practices that ideally result in improved capacities, both technical and managerial, on the governance of transboundary aquifers. So again, we're looking at reforming, updating legal, policy, institutional arrangements, strengthening capacity, and implementing collective measures at different levels, both national and regional. So just to give you an overview of this third phase, we have 4 pillars to work with. And these, of course, are for the project as a whole. And the project also covers groundwater management in Central America, as well as in Central Asia. So this is also cross-cutting for the 3 areas. So the first one is really about establishment of institutional and technical capacities on groundwater governance in RBOs, and specifically for Africa. Second is about regional cooperation through investments in aquifer commission partnerships and networks. The third one is about groundwater resources quality, which was a bit under focused in the previous two phases. So this phase really would like to focus a bit more on the quality of water and groundwater management as well. And the last one is more about improvement of transboundary aquifers and shared groundwater resource diplomacy. So in terms of outcomes for this project, and it repeats a bit of course the pillars, it's about strengthening these capacities as a first outcome, reinforcing the regional cooperation, focusing more on transboundary groundwater quality, as well as strengthening public awareness and groundwater resource diplomacy. So if you could go more into detail, and I think it becomes more interesting in terms of what activities are actually foreseen to be organized in these 3 years. And I think you'll see that several of them already have been put in the pipeline, and we'll expect many of them to materialize in the next few months. So the first type of activities under output 1 is to support the RBOs and RCs to include groundwater governance principles. And I think several of you have been attending also the groundwater governance webinar, which was held only a few weeks ago. But also looking at operationalization of groundwater governance cooperation mechanisms. And I think the STAS was one of the success stories of the project, even at global level. And this also gives us a pathway for further work in the same, as well as in other RBOs. We're also looking at training of focal points. And I think there we still have to understand well which focal points we would like to engage and which also are proposed by the RBOs, specifically on strengthening capacities on the law of transboundary aquifers and related United Nations General Conference resolutions. So also a specific item here, and I think it put it in red because it's actually the objective of today, is about identification and dissemination of lessons learned and best practices of effective transboundary groundwater governance mechanisms. I think today we're here to take stock of those lessons. Secondly, we also look at facilitation of sharing of data and information between countries, specifically transboundary data management and information sharing systems. And I think we have an example from the Stamperit where this has been put in place in the phase 2. And we're also looking at strengthening those capacities, but also expanding to other areas. So again, there we're looking at capacity building workshops, which are now being planned, which will likely happen at the beginning of next year to strengthen transboundary data management. We also, of course, would like to strengthen the networking. And here we are identifying national focal points together with SADC-GMI, which is a similar objective. So I think we can join forces there and identify how we can strengthen regional networks, national focal points, also part of the RBOs, to make sure we really have a network of people we can work with. Specifically also for the regional meetings, including the SDG indicator 6.5.2 on transboundary aquifers. So in this sense, also this regional strategy building becomes important. And of course, beyond SADC, there's other networks such as AMCAO, which we also would like to engage with to make sure that information and experiences from this region can also be used in other regions. In this sense, we're looking at establishing a comparative baseline assessment of transboundary aquifers for the whole of Africa. And as I mentioned, again, on the monitoring of SDG indicator 6.5.2 on transboundary water cooperation, for which UNESCO is a co-custodian for that indicator. In terms of outcome 3, we're looking at specific activities related to transboundary aquifer quality protection. And I think this is certainly something where we can identify more work to be done in the region, identify, for example, groundwater vulnerability maps. This is an activity which likely will start only mid-2021. But also establishing regional working groups on groundwater quality, including academia. And I think also Pete made the case of the importance of academia in the management of groundwater specifically. And last is about outputs and activities under outcome 4. And there we're looking at strengthening or identifying the capacity gaps in groundwater and priority needs in higher education. And for that, we'll be working together with our NEPAD Centers of Excellence. And I think some of them are actually on the call today. But also strengthening capacity building workshops for young professionals in transboundary water law, groundwater governance, hydro diplomacy, and water and gender. So of course, that's something we've been currently developing, and I expect also early 2021, we will be engaging with our partners to deliver on that. For example, with WaterNet as one of the partners. but also looking at improving communication strategies. And this we're already piloting in some of the RBOs. And we hope also to support some of the, let's say, new RBOs in the project to with their communication strategies. And finally, we also have the objective to provide policy briefs on transboundary groundwater management. And actually, I put it in red again because the outcome of this workshop is actually development of that policy brief. So this is actually a direct input to that policy brief. And just maybe to give you some advances before I finish, I think you all were part of the introductory webinar that was held on 6th of October, where we had more than 140 participants. And actually, which was an introduction to the course that will be starting in a week or two from now. A similar one was held on groundwater modeling, I think 2 weeks ago again. And this was already having 70 plus participants. The difference, of course, is because the groundwater governance will be done at regional level for whole of Africa, while the modeling will be focusing on the stamp rates. And we also would like to ensure we have our RBOs from the region actively engaging in that work. And it's also much more hands-on as well. So we also, for our, let's say, continued capacity building and to mitigate the impacts of COVID-19, we launched an open learning platform, which allows for free and self-paced training online. So you can also find those courses that I just mentioned over there. In particular, you can access and, let's say, participate in both the Introduction to Groundwater Governance, which is set to start on 7 December, as well as the Introduction to Groundwater Modeling, which is set to start on December 14. And with that, I would just like to stop here. And I really want to give more time to the discussions and to lessons learned. So we can, of course, answer any questions and continue with the program. Thank you very much.
Thank you, Koen, for that detailed description of the Gigreta Phase 3. So colleagues, we have heard where the project is coming from and where the project is going and what we are tending to achieve with the project, especially in Phase 3, based on what we have achieved in Phase 2. The next session is a panel discussion which talks to lessons learned from the Gigreta Phase 2 and Phase 1. And this will involve a discussion with national coordinators. And the moderator is James Sauramba. I'll hand over to you, James, if you are ready. So the national panel, the national coordinators are namely the riparian states of the temperate transboundary aquifer system, which is Namibia, South Africa, and Botswana. So James, over to you. Thank you.
Good afternoon, everyone. As Brighton has indicated, I have the task of facilitating this upcoming session where you can see my screen, right?
Yes, James, I can.
Okay, thank you. So my task is relatively simple. I was requested to facilitate a panel discussion by the national focal persons from the respective riparian states of Botswana, Namibia, and the Republic of South Africa. So in name, that is from South Africa, we've got Kwazi. From Botswana, we've got Prof. Kinabatu. And from Namibia, we've got Mr. Bertram Swartz. So colleagues, to start with, we are in a lesson learning engagement and would like to probe the issues that you have picked in the implementation of the last phase, 2 phases of the Gigreta project. There were 3 main objectives that were set in overall to reinforce the capacity of the member states in managing groundwater resources through tailored capacity building. And I think this is something that Prof. Kinabato has really gone through, which has also been reinforced in the future as we move into Gigreta 3. The second objective is to strengthen cooperation among the countries sharing the aquifers through different mechanisms, as well as to develop long-term strategies for the monitoring and governance of the transboundary aquifers. So I only have 2 questions. They may be very unfair, but I guess that's the idea as well, to try and get your very raw thinking about how these projects, these 2 projects phases, phase 1 and 2 went. In terms of the 3 key objectives, to answer the question of which one of the 3 was most successful in your view, because we know that 3 riparian states are converging to try and collaborate in the management of this transboundary aquifer. But obviously there are ways in which we experience this engagement from a national perspective. So from that angle, which one of the 3 objectives was most successful, and why do you think that was most successful than the other 2? And in the same vein, you could also answer the question, what didn't work? I'm sure we are always good at also talking about what is always working, but it is also good to talk about what you think didn't work from your perspective in collaborating on this project. And how do you think we should avoid the same as we move into the next phase of this project, Greta 3? So those are the 2 questions I would like the panelists coming from the respective member states to address moving forward. Maybe I'll use the alphabet, and in my context, the alphabet starts from N, and it goes up to B. Namibia would like to start.
James, colleagues, thank you very much. I think, can you hear me?
Yes, Bertram, we can hear you.
All right. Yes, thank you very much for the questions and for inviting me to this panel, James, and welcome to all the participants. You know, looking at these questions, you know, these 3 objectives, which one was the most successful? I think if I had to choose one of them, I think it's the cooperation, you know, strengthening the cooperation amongst the countries. I think everything hinged around that. I mean, you can study all you want on an aquifer system, be it transboundary or otherwise. But if there's no synergy, no working together, I think this is the objective that was most successful. I think working well with the other states. I think when it was first introduced, the MCC, you know, was more or less foreign to a lot of us, although you know, we latched onto it quite well, you know, through the help of UNESCO IHP, and I think this objective was definitely the most successful. When we're looking at, you know, why didn't the other ones work? I think, you know, looking at what the need was in Namibia, you know, and you know, the use, which we see that it's definitely more from the Namibian side, from this aquifer system. You know, you look at some of the boreholes that into the deeper aquifer was definitely in the Namibian side. So a lot of the information was from there. So I think that's why some of these didn't work. You know, trying to understand into some of the other aquifer systems a bit better. But you know, we could say that we'd like to learn from these 2 phases, and we will definitely learn from them going forward. Namibia is also working on similar approaches with other transboundary water resources. So we definitely will look at what worked for us, although, you know, you've got a different riparian state, other role players. So it won't be the same, but it will be similar. You can take a lot from that going forward. So I don't know, you know, Pete wanted me to talk to you about you know, what Stumpage stands for, but I'm not going to go into that right now. I think that was supposed to be a discussion during a coffee break or something like that. I'll give Pete, or I don't know how your alphabet works, other way around, maybe to give us some more discussions, and as a panel we can discuss these matters. Thanks, James.
Thank you, Bertram. You covered some pertinent points there. I think you highlighted one of the most important, or the successes. What worked very well was the cooperation. I believe before this project, you were working as independent member states on the transboundary aquifer, and this the intervention of phase 1 and 2 got you to work together as riparian states sharing the transboundary aquifer. And I seem to get that you also, what probably didn't work is, if I read between the lines, it could be the replicability of the results to other TBAs. Would I be correct in that context, that you think you cannot take the lessons learned and apply them as they are in other TBAs that you are sharing with other member states? Maybe we can pack it for now, and we can move on to the next presentation, and you can think about it. Then after N, the next one is South Africa. Kwazi, over to you.
Thank you. I hope you can hear me. I took off my earphones.
I can hear you.
Yes, I can say as well, I can agree with Bertram here. I would say the most successful one of the objectives was the second one of the cooperation mechanism. And the reason why it worked so easily or much better in this instance is because we already had a well-developed ORASECOM. And inside the ORASECOM, there is already a groundwater hydrology committee. And it was easy to just develop this mechanism and then agree on it. And then someone can take it as, I mean, it's a good vehicle forward to address the issues related to groundwater. And of course, the cooperation mechanism that was developed from there, I see it as a good vehicle. But again, as you say, if you want to replicate this to other places, to other transboundary aquifers, there's no reason why the other transboundary aquifers can expand, because this one was just looking at certain, I would say this was the initial of the TDA process, and it's looking at specific objectives. So I can think of the Ramutswa, which expanded and included the managed aquifer recharge aspects and the agricultural aspects. But going forward to, I mean, thinking about cooperation mechanisms, that's the one that worked well. And I wouldn't say the others did not work well, but they were a bit lagging, I can say. And not to say the outcomes were, but probably some activities inside each outcomes. Just one, which is, it could be seen as a small issue, but it really took us a long time to get to agree on other things. One of the things was to say, we cannot allow, in a sharing space, we cannot allow one country imposing their protection tools or groundwater protection tools to other countries. For example, we had to harmonize some parameters, let's say for quality purposes. We had to agree which standards we should follow when it comes to the SADC. Do we follow the WHO standards? Do we follow the Namibian standards, which are probably stricter than the WHO? Or we follow the South African? Or there was a long discussion around that. So I think going forward, those things should not be overlooked. They are important in agreeing on this, on how to protect the transboundary aquifer. And the other issue I think can disturb the process of joint governance or cooperative governance would be one country not putting effort into the process of trying to protect or to govern the groundwater resources in a joint manner. I can just think of some cases where maybe, let me say in the South African case, in the SADC, we are not using our component of the SADC for supply purposes. It's falling within the Kgalagadi Transfrontier Park, which is a conservation area, and they're using it for tourism and I guess for stock watering and stuff like that. It's very minimal the way we use it. We could have said, no, we are not interested in participating in this. But looking at long-term, possible long-term impacts like climate change or what can happen in one country, maybe there was a thought that from the Namibian side, there's a prospect of coal mining, which has not happened yet. Maybe one day in the near future, they would decide to look at that. And that could impact on the downstream countries. So they need to participate in this process, not because you are using the resource, the transboundary aquifer, but because you want to avoid conflicts, potential conflicts in the long-term period. I think it's not, that's what I was saying, it's just the issues inside the outcome that could disturb the process, but it's not that other processes failed, because I know some of the processes were moved to the next phase because they couldn't, for very serious reasons, be undertaken in phase 2. So that would be my thinking so far.
Thank you, Kwasi, for that very concise and clear elaboration of your experiences as the Republic of South Africa. I captured the fact that you noted the existence of a strong ORASECOM and an existence of the Groundwater Hydrology Committee, which found, which was easy to coordinate and to discuss the issues. So there was already a platform of some kind. I guess that's a very important lesson learned. I also picked your concurrence with the Republic of Namibia, that cooperation was one of the key issues that you benefited. And then I captured the issue of lengthy negotiation processes to build consensus. I think you talked about the need to have common standards without one imposing their own, because that's not where it works. And then the potential risk of having an equal interest in the said transboundary aquifer, where in the Republic of South Africa it's in a game, did you say the game reserve or a national?
It's a conservation area.
Conservation area. Whereas in Namibia, there's potential for coal mining, and the disparities in the utilization or potential utilization of the transboundary aquifer brings about different dynamics, which the member states have to take cognizance of if they are to have a joint important management of the said transboundary aquifer. I think those are important lessons learned that you have captured from the Republic of South Africa. At this juncture, let me move on to Botswana through Prof. Kinabato. Thank you, Kwasi.
Yeah, thank you, James. Am I audible?
Yes, we hear you and we see you nicely.
Oh, thank you. Yeah, I really thank my core focal points from Namibia and Botswana. And I think really this is a testament of a long-term relationship that was developed over the years through this project, particularly in the stars. So I would really say the same thing as they have said, and also just to add a few over and above what they have said. I can't really agree more with them. Perhaps in addition to what they said, one of the things, I would say two main ones. One is the time frame for the project itself. I think when this project finishes, it would have taken a little over 10 years from 2013 to 2022, which is good because I think this the stamp rate was a kind of a groundbreaking in terms of transboundary water cooperation and also setting the scene and also the pace for other TBAs in Southern Africa. And the issue then is how do we then shorten the process, because the resources may not always be there. In this case, we are so blessed that we have the support mainly from SDC and also other bodies such as UNESCO and IGRE. But in other TBAs, under normal circumstances, the TBA assessment will even be less than a year. So the probably moving forward is not to say it didn't really was not worth it, but it's just to say, I think maybe let's find a way of shortening the process if possible. And then the other thing is that in terms of the findings, one of the key findings was the issue of the data gaps, particularly for deeper aquifers, which actually will continue the story. As you've seen from my presentation, is that when you look at the cross sections, moving from Namibia, the information is much more comprehensive, even for the deeper aquifers. But when you move into Botswana and also South Africa, you begin to have question marks and gaps for deeper aquifers. So we had hoped that by now, some of those gaps would have been filled in terms of maybe drilling more boreholes. We know the challenges, of course, that sometimes it depends on the geology and the lithology in terms of maybe having to dig through things like basalt that you need to go deeper. But there are areas where, in terms of the more friendlier regimes, you can actually move further down for the sandstones in the area. But up to now, those kind of gap filling has not really been done. And it is probably a challenge for the three countries to make sure that the gaps are being filled for us to fulfill one of the objectives of having a science-based policies on groundwater. And then maybe lastly is probably tied to what I mentioned earlier on, James, that I know in phase 3, we will be developing a strategic action plan for the stars. My feeling is that it could have come maybe much earlier, but it's not. It's also good that because we have now looked at the bigger picture, but as I said, with other TBAs, the resources may not be available. So trying to shorten the time is also very paramount here. And probably in my conclusion, James, I would just say, you see, I think the reason why it worked for Stampede is not only for that Orascom had a structure, which I agree with, as my colleague said, but also the involvement of the high-level political players. I think they were always behind us to want us to inform them of the processes and what they needed to do. So I think the buy-in is also very important as we move forward in the other TBAs. And what is even more encouraging, James, is that we are seeing in the coming of other TBAs within the region. And this is really very commendable, because moving forward at the end, it's not about any TBA, but it's about all the TBAs ticking the boxes that players like SADC-GMI and so on and so forth would want to be ticked in the future. So I think with those few remarks, thank you, James and colleagues.
Thank you, Prof, for those very important observations and lessons shared in respect of your experiences implementing phase 1 and 2 in your capacity as the national focal point for Botswana. I have also captured, I see I'm in the last minute, I've noted on the cooperation you have also agreed, but attributed it to the buy-in that came from the highest level. And I think this is a very important point in regard to the fact that as we at SADC-GMI roll out the studies in the transboundary aquifers, we have also learned the importance of the highest level buy-in of these initiatives. I note you also mentioned one small downside of the previous experience over 10 years, and you think maybe we needed, or we need to shorten the time period that we undertake certain of these activities. And I think one of these has started being rolled out in the initiatives that we are implementing at SADC-GMI. You also indicate in your experiences the issue of data gaps and the need to possibly implement initiatives that allow the collection of additional data that can be used to close those gaps that we need to close. And finally, you also highlighted in very clear terms the importance of developing the SAP earlier than what could be the case under the circumstances, as this would then input and support the joint collaboration of the parties. I note that I was given up to 10 to 3, but maybe can I borrow a few more minutes and ask, I think, Bertram, you wanted to come in a little bit after the remarks I made before I hand over back to the chair.
Yes, James, you may.
Thank you, Brighton.
Yeah, no, I think James, I think Prof. Kinabatu and Kwazi has really covered a lot of these issues. I maybe have one point only. It's on the output regarding the long-term strategies, and the governance of these transboundary water resources, as much as it's being covered under the multi-country cooperation mechanisms within the River Basin commissions. It's notoriously difficult, even at national level to do groundwater governance, knowing the fact that you have to lobby a lot for into your principles regarding groundwater and all this. So taking it a step up is also difficult. So I think that in itself is a reason why that objective is very difficult to achieve. But Prof. Kinabatu has definitely touched on a very important point, and you've mentioned as well that the buy-in from the beginning, political buy-in is vitally important, and we definitely need to and get get all the principles on board before we set the ball rolling and in motion. And by saying that the River Basin, the commissioners and all that, before you start working on a project, get that ball rolling. So yeah, I think that's more or less from our side. Yeah, thanks. Over to you, Brighton.
Thank you, Bertram.
Go ahead,
let me thank the panelists for a very insightful discussion on the lessons that they learned as the respective riparian states working on the STARS project with support from UNESCO IHP in the past 8 years now until the start of the Greta 3. And with that, thank you, colleagues. I hand over the chair to the chair for continuation. Thank you.
Thank you, James. Thank you, National Focal Persons, for the STAMBRET project. You notice on our project, on our program, we are going straight into a panel discussion to look at how to replicate the lessons learned from the STARS in other RBOs and TBAs. We have constituted this panel as follows. We have Dumisani Mzibele from the SADC Secretariat. Welcome, Dumisani. We have Jonathan Lautze from the International Water Management Institute. Welcome, Jonathan. We have Kevin Peterson, who is with the University of the Western Cape and is also an independent consultant. Welcome, Dr. Peterson. We have Neno Kukrich, who is with the UN IGRAC. Welcome, Dr. Kukrich. And lastly, but not least, we are joined once more again by Professor Kinabatho. I'm particularly requesting Professor Kinabatho in this panel discussion to please wear two hats. One is an academic in the region, and two, to also draw from your knowledge of river basin organizations, having worked so much with Orasecom. We had invited Orasecom and Zamcom to this panel, but unfortunately they could not make it because of conflicting calendars. So that is our panel for this afternoon, colleagues and participants and attendees. Let me once more remind you that this discussion is not only limited to the people on the panel. I see we have one question in the QA. We'll find time towards the end of this discussion to come back to it. You are welcome to post comments, reactions, suggestions in the chat boxes and in the QA chat box as well. And we will, time permitting, come back to these questions and ask our panelists to respond to them. So without further ado, I will pose a set of questions to our panelists to kickstart the discussion. Panelists, I might follow up with some follow-up questions just to clarify issues and also to get the discussion going. So my first question goes to Dumisani, the SADC Secretariat. And what I would want to ask Mr. Mzibela is the role that has been played by this the Greta Phase 2 through a pilot in the STAMBRET aquifer in relation to fulfilling the regional plans, and notably the Regional Strategic Action Plan 4 from 2016 to 2020. Thank you. Dumisani, please.
Thank you very much, Chair. Good afternoon, everybody. My response, it has been quite a great experience for the region, this particular project, especially in relation to the issues of transboundary water cooperation. Many of you will remember that in the past 2 decades, our fathers of the sector decided that when we define water cause in the issue of transboundary water cooperation, embraces both surface and groundwater, being seen as a system that consists of a unitary whole by the mere fact of virtue of their interrelation. So but you realize when you read our protocol that we were a bit shy in saying exactly in the issue of groundwater, transboundary cooperation, what would it entail? So this project has really assisted us to understand better the issue of conjunctive management of transboundary waters. So in relation to our regional strategic action plan, the 4th phase, which is completing next month, out of the 4 objectives or objective areas in the strategy action plan, which are institutionalizing groundwater, which happened through GMI, SADC-GMI, capacity building of institutions, RPO, member states, and the GMI itself. The next one being advancing knowledge on transboundary water and national groundwater management. Lastly, being the promoting groundwater infrastructure development. You realize that this particular project responded directly to the objective number 2 area on capacity building of institutions, the way it dealt with the blending of researcher and practitioners in the knowledge generation and understanding of the shared aquifer system. So really, it has really added value to this particular objective. And the collaboration forum that were set up for both data collection and monitoring. And then also in advancing the knowledge of transboundary groundwater management. So the products that have come up have really assisted us to better understand what it means in terms of the issues and the dynamics, let alone share the cooperation mechanism, the thought process. So really it's, for me, is a real outputs that will assist the region going forward that have been delivered in this phase. These particular activities responded strongly, Chair, to our regional water program strategic action plan 4. Thank you.
Thank you, Dumisani, for that elaborate response and also for highlighting the main contribution to the regional plans in terms of capacity building that we got through the GIGRETA project as piloted in the STARS project in the SADC region. I will leave Dumisani for now and go to Jonathan Lautze from the International Water Management Institute. Jonathan, you have requested to respond through maybe a short slide or some few slides. I think we can.
That's right, just 4.
4 slides. I think we can have that. You can share your slides. But my question to you relates to the IMI has been quite active in the SADC region, and you have been involved in a couple of transboundary aquifer studies, and notably the Ramotswa project. And I would wish if you can talk to the MCCM mechanism or the MCCM model and draw some parallels between the model that was also set up in the Ramotswa project, which is the project advisory committee, and maybe try and make a comparison between these two and see what lessons can be drawn from the first model, which is the MCC model, and how the Ramotswa Advisory Committee was set up around the same model, or what deviations did you come up with? Thank you, Jonathan.
Okay, good. Thanks, Brighton. Let me just first say it's been quite a while since I've heard some people's voices, Tokozani and James and whatnot. It's nice to be a part of the community again in this unusual times we find ourselves. And it's also nice to see a session now on transboundary aquifer management, and then also in a couple of days another one. So the attention it's getting is great. So zipping in and trying to work towards responding to your question. You know, when you ask about the Ramotswa, which is very valid, you know, we had 4 years, I think, on aggregate, a project focus on the Ramotswa. I just felt it was necessary to give it just a tiny bit of context to frame it alongside the work on the Stamprey. So just very briefly, so as you hopefully can see on the slide, we had 2 phases of Ramotswa, in many ways analogous to the 2 phases of Greta, although Greta started slightly earlier, it seems, but we ended very similar times, our phase 2, I think in the early part of 2019. When you compare Ramotswa and Stampriet, Ramotswa is much smaller geographically. So it's less than 5,000 square kilometers. If I heard Pete earlier correctly, I think he said Stampriet is more than 50,000. Nonetheless, the population is bigger in Ramotswa, substantially bigger than in the Stampriet. And then the other nuance when you compare these two is that Ramotswa falls in the Limpopo Basin. And this is particularly relevant in terms of the RBO discussions, which it might be interesting for Pete to weigh in on in a bit. So Ramotswa falls in the Limpopo, and then Stampriet falls in the Orange Senku. And as I said, the implications for RBO dynamics are strong because of that. And just on the map you see on the right hand of your screen, so that, as I said, the Stampriet is much larger, it's a big circle, and then the Ramotswa is a small circle there, shared by Botswana, South Africa. Then when you look back at these project designs, it's interesting because I had the benefit of collaborating with a few people on Greta to compare. There were a lot of intersections, a lot of similarities between the two. The language may not have been exactly the same, but basically there was a baseline report or transboundary aquifer assessment. It was kind of a foundation of the projects. There was equally a hydrogeological assessment. Information management systems were undertaken and dialogues. There were some differences, nonetheless, in terms of the project approaches. Ramotswa did work on ag water solutions. We did work on managed aquifer recharge, and we did a joint strategic action plan. By contrast, I think the Stampriet placed more emphasis on the MCCM. So there's no right or wrong, but there's differences which are worthy of noting. And then just in brief, in a very nutshell, that I'm not going to capture everything, but if I'm just to kind of frame some of the key highlights of the Ramotswa project, we refined the delineation of the aquifer extent of where exactly Ramotswa is. You see on the right hand of your screen, I think that the kind of straight looking lines that look kind of rectangular in red were the starting point. And then we eventually, through the project, refined that to a much tighter area of focus that's more aligned with the precise boundaries of the aquifer. We also synthesized within this TDA, we synthesized key knowledge from the 2 countries, distilled them into 5 priority issues. As I said earlier, we investigated MARP, managed aquifer recharge potential, identified water quality risks associated with pit latrine, and then we had some strong interns, like there was a lady named Bonnie that drove work around drought and its links to water quality and health. And then, as I said earlier, shared data and information was an element of our work. And then ultimately, the SAP, the Strategic Action Plan, looking at ways and actions to take things forward, was a final area. So, okay, with that bit of context, maybe now I'll move into your question, Brighton. I just felt it was good to give a little bit of context on the Ramotswa. And I wanted to say, when I look back and I think about the Greta project and the synergies between Ramotswa, I have to say I look back very fondly at 2 joint workshops we had with Greta and others. I think SADC-GMI was also a partner on the second of the 2. And they were excellent opportunities for exchange across the 2 projects, which, as I said earlier, were in many ways parallel. And I think those were real highlights. And then zooming into that specific question around this Ramotswa Advisory Committee. So in many ways, this was viewed as a bridge beyond the project, 2 different regional bodies. As I said, I think at the outset of this presentation, because the Ramotswa falls in Limpopo, in our case, that meant more engagement with LIMCOM. And then because the Ramotswa is shared by Botswana, South Africa, that meant engagement with a body called the JPTC, the Joint Permanent Technical Committee. And when I directly compare the MCCM to our work in the Program Advisory Committee, I view this committee in many ways as a precursor to getting something like, or finalizing something like an MCCM with these regional bodies to kind of sustain work. So I think the MCCM in building on the Ramotswa, or in the Ramotswa, or between the Ramotswa and Limpopo, LIMCOM, would be a next step. And then, when I conclude this short talk or short intervention, I just did want to highlight again, underline this kind of different basin context here. And I think this came out of an earlier document I had produced. That recommendation was consider the basin-wide RBO. And I've noted, you said, an aim of this session is to look towards other aquifers in the region. The capacity or strength of that basin RBO to kind of foster linkage with a specific transboundary aquifer, I think would be kind of a key ingredient towards fostering and sustaining work done in an aquifer. So the landscape, I think, in Orange Senku and Limpopo were not exactly the same. And I use the word were there in particular, underline that, because I'll come back to that in a second. But yeah, at the time of these projects, I think Orascom was probably further along. There was a groundwater task team. There was a very nice linkage there to work on a shared aquifer like the Stamprey. Remotswa at the time of the project didn't have that benefit. And now, I mean, as some of us are aware, there's now been a Limpopo Groundwater Committee that's very recently been created. So that may create new opportunities for linkage. But again, looking to other aquifers in the region on which we may seek to undertake similar interventions, looking at the capacity and receptiveness of an RBO may be a key thing. Okay, thank you, Brighton.
Thank you, Jonathan. I like the last point where you say all this has to be done also within the context of the capacity of the RBO to receive and host the management and governance interventions that might come along the TBA studies. Let me go next to Kevin, Dr. Kevin Peterson. And Dr. Peterson, my question relates to the issue of the, maybe before I come to you, Dr. Peterson, just allow me a second. Can I ask all the panelists to please switch on their cameras? I'm sure the organizers of the conference would want to have some recordings and see the panel as it is discussing these issues. So please, if you can, let's allow the participants and the attendees to see you. So I was saying, Dr. Peterson, we have heard from Professor Kinabatho and Kuhn that one of the underpinnings of the phase 1 project and probably phase 2 of the Gigreta and the STARS project was to get a sound understanding of the physical hydrogeology of the TBA. And I think Professor Kinabatho has also labored around this point of lack of data or lack of understanding, especially when you look at the cross sections that he projected, where you have a lot of question marks coming in as one goes along a section line, maybe into one of the riparian states. And as much as this is desirable, we have a challenge of limited resources. We have spoken about capacity. I think Dumisani has spoken about that. What would you think are the key issues, the key basics that need to be put in place for effective, that need to be understood as a base for effective groundwater management in the TBAs? Thank you.
Thank you, Brighton. And may I say first, as hydrogeologists, we never have enough data, and data availability is always a problem. So if we have 1 million water points, we'll not be happy as hydrogeologists. But I think it's important to recognize that decisions around groundwater management or water resource management is taken now based on the best available knowledge. And as you move on, you put in your systems in place to hopefully to collect the data to better your decision making as you go through the process. I think a bigger challenge for me is not so much always data availability and gaps in data, but it's about data access and exchange of information. And you've highlighted the issue around the greater process where we've talked about trust. Trust is built over time, and it's only through those through time and building that relationships with colleagues that you start to kind of build those linkages where you get access to data, access to information, and and then basically exchange of that information. Certainly one of the biggest issues of putting the necessary protocols in place, and sometimes the bureaucratic barriers are sometimes overwhelming. So within the context of data, our challenge is perhaps to use different types of data, whether it's satellite or airborne, Earth observation data, groundwater-based geophysics data, as was shown in the Ramochwa Basin, legacy documents and documents that sits within ministries that is not readily available, hydrogeological mapping, and also on-site point observations, but also now data that's collected through citizen science. So I think the whole issue then comes to what extent do you start integrating that data and processing the data to get a good understanding of the groundwater system that you are working or dealing with. So in my kind of sense and experience, I think what is very important in terms of understanding a groundwater system is to build a good geological model of the system, and then to translate this geological model into a conceptual hydrogeological model. And I think through that process, integrating hydrology and hydrology, you basically get a good understanding of the groundwater system, and you will always have data gaps, and you will always have knowledge, but integrating expert knowledge, expert insights into that understanding goes a long way in terms of assisting management decisions, in terms of how to deal with the system. I think coming back to understanding the system boundaries, previously it was mostly focused on stratigraphy considerations, but what is coming more and more to the fore is the integration of tectonics, aquifer systems, or hydraulic characteristics of that systems, flow systems, recharge and discharge zones, and then basically combining the analysis. And I think that is the point that I want to make, is how the combination of that data. You may not know the whole story, but by integrating that data source, you can start combining a perspective or a sense of how the system, and how the system behaves. So the point really is basically to kind of build on what you have, and you build your narrative around that. And I think what I just want to highlight here is that groundwater quality is a critical issue, and this is sorely neglected in the region in terms of data sources and data information. So I think in conclusion, just to highlight the issue of building a good geological model, which would translate into a good groundwater conceptual model, and then basically trying to understand your system boundaries, and then also understanding groundwater quality issues. Thanks, Brighton.
Thank you, Dr. Peterson. I think next I'll go to Dr. Cookridge. But before I come to you, Dr. Cookridge, I just have a small quick follow-up question for Dr. Peterson. One thing that you would note that has happened within the Stambret aquifer system is that I think of all the 5 transboundary aquifers, Jonathan, thank you for that correction. There are 5 actually, not 4. Is that we probably is the only one where we have developed a numerical groundwater model. And I'm not sure what will be the lessons learned from this experience and the other TBAs, and what will be your reaction to that? Because we have 4 that came after, and no attempt has been done on a numerical model, and the Stambret has developed a numerical model. So maybe just briefly, what would be your thoughts around that development? Thank you.
So if you look at the work that we've done in the Eastern Kalahari Karoo Basin, that is exactly the recommendation that we make to build a groundwater numerical model. The issue is whether it is a regional model or whether it is a suite of models focused on particular areas of concern or issues related to that. That is the challenge that you have in terms of, I guess the models will be guided by the type of questions and the type of issues that you need to resolve. So certainly that is a good next step. But the model, when I was working a lot in the mining space, we always say the best model is the one with no data, because you can't prove the model wrong. So it comes back to the issue that whatever numerical model or whatever model you build, it will need to be supported by let's call it the real world conditions. And sometimes I feel an analytical model and a good conceptual hydrogeology model is sometimes equally as effective to support decision making. Sometimes we build models for modeling's sake.
Thank you, Dr. Peterson. I think we will.
Brighton. Ramotswa actually did do a model also. Girma drove that work. But I mean, it faced similar challenges to, I think, the ones that Kevin is alluding to. That data was patchy at times, and I think we could have done more with a stronger set of data. But Girma Ibrahim did drive model development for the Ramotswa.
Thank you very much, Jonathan. Yeah, I remember very well the Ramotswa numerical model. I had wanted to give Dr. Kukrich the last chance to speak, but because Kevin has raised a lot of issues that probably are at the heart of IGRAC and the work they've been leading in the region, which basically evolve around data collection and data management. Dr. Kukrich, my question is, you have been involved with the Ramotswa and mainly on the Ramotswa Information Management System. And you have also been involved as IGRAC in a couple of projects with the SADC-GMI on data collection and data sharing initiatives. And Dr. Peterson has highlighted, I think in his contribution, in his response to the question, a lot of data issues. And looking back at the approach that was done in the STARS phase 1 and phase 2, and the projects that you have implemented, notably the Ramotswa Information Management System, how would you think the GIGRETA and the STARS project have influenced your approaches? And also, I would also ask you to look forward and say, what would be your advice to the GIGRETA phase 3 projects around the issues of data collection, data management, and data sharing, given the experience of SADC around those issues of IGRAC around those issues in the SADC region? Dr. Kukrich, please.
Thank you, Brighton. Do you hear me?
Yes, I can hear you, but you can improve maybe. It's a bit, yeah, it's better now.
Okay, well, let me see. Can I improve that? Is this better? No?
We can hear you. It's not bad, but yeah, you can go ahead. It's fine.
Let me see. Now, can you hear me?
Yes, you can go ahead.
Okay, good. So basically, yes, good afternoon, and for this opportunity to join you today. About transboundary aquifers in SADC. Well, the first inventory we did in 2004, actually. That was assignment from UNESCO, as usual. And so our experience goes a little bit further than Ramotswa and Greta.
So of course, you know, I could react on various issues here also about modeling, but let me stick to the question you raised here. First about indeed, IGREC was involved together with the INVI and member states in Ramotswa, developing a Ramotswa information management system. And I was amazed how many facts Jonathan put in just a few minutes, but I completely understand him because it was 4 years of hard work and it was a great project. And it's pity that I don't have here a snapshot of RIMS system, but eventually that was very good system. Well, indeed, we did it in Ramotswa, and IGREC was commissioned by UNESCO HP, involved in Greta first phase, not second. And basically, we did what we are doing usually, that's assessment and providing information system. This needs to be seen also in a context of TWAP several years ago, which was transboundary assessment to water resources, global water resources. Within that huge GEF project, there was assessment methodology prepared, and then Greta was meant to extend that methodology to aquifer scale, from regional to aquifer scale. So there are still 3 exemplary pilot projects. Stampik is one, Pritashkent in Central Asia, second, and Trifinio in South America, third one. To come back to Greta, so what we see in Greta, and in all the other projects, we did a so-called first phase of GEF projects, and that's transboundary diagnostic analysis. It's what also Kevin mentioned, trust and cooperation crucial. And so in standard GEF procedure, but also in standard transboundary procedure, second step, you have these coordination mechanisms, and Greta did it great in the second phase. And then third phase is putting together strategic action plan and executing that together. So I'm very pleased to see that Greta and IGREC could assist in promoting the use of information management systems, which in the meantime has become the obligatory tool when people deal with transboundary aquifers. I would also have a couple of advice, and one of them is on protocols, because after several years working with transboundary data exchange, we see that the countries don't actively engage in a continuous sharing of data and information, and protocols of groundwater data exchange could be very instrumental here. So to agree what to share, how, when, etc. And we talked about Ramotswa. Actually, IGREC developed a draft protocol for Ramotswa aquifer as a part of USAID project, Big Data for Transboundary Groundwater Management. And so that might be used as a sample for developing protocols for transboundary aquifers, including Greta. And on information management systems, just to mention that technology is developing very quickly. And now free and open source software is available. And we see a lot of attempts of the countries and activities to develop own information systems. I could count several of them. So using this new technology and free and open source, the access to data, what Kevin was mentioning, it's becoming much better. And SADC-GMI actually is developing a new version of its groundwater information system using this new technology. So it will be very exemplary for the region. That's for now. Thank you.
I think you raised, thank you, Dr. Kukridge. I think you raised a very important point of open source software. And also this touches around the issues of cost of maintenance of the databases and sharing of data in the region. And also you also pointed to the recent developments around the SADC GIP, where the SADC-GMI has tried to enhance the functionalities of the GIP by migrating to GeoNote. And also for the advice that we have given to the greater phase 3 around the issues of data sharing and management, and also protocols that relate to data. Thank you for that. We might come back to you depending on time. For now, I would want to pose a fairly general question to Professor Kinabatho. And Prof, I'll ask you to draw from your experiences with Orasecom and also your general experiences in the region with RBOs and what you might know is happening in the various RBOs. My first question will be, you have been involved with Orasecom before and after, and even up to now from phase 1, before phase 1 of the Gigreta project, and you are still with Gigreta and Orasecom. On a general note, have you noticed any improvements in terms of groundwater management in the basin? Yes, maybe just from your experiences, from where before Gigreta came in up to now, what would you think, what would you point out as the major issues or overall improvements in groundwater management? Thank you, Prof.
Thank you, Brighton, for your question. And let me also thank my fellow panelists. I think they have all raised very important issues around the questions that you posed to them. And it's a very informative and rich discussion, even for the future. With the specific question that you have asked, I think let me first of all say that, as I alluded to earlier on, in the river basins existing in the Southern African region, Orasecom is fairly the oldest, and it has actually been dealing with water resources issues, although mainly it was more on the surface water. But I think it is also the first to include groundwater directly, particularly with the establishment of the technical teams, this one being the Groundwater Hydrology Committee. So I think that credit should be given to them for having established explicitly the Groundwater Hydrology Committee. And in this context, you realize that the LIMCOM, the OCACOM and the ZAMCOM are not at the same level in terms of this establishment that I have just mentioned. And I think Jonathan will also agree with me that when, fortunately, I was also involved with the Ramoto as well. So he alluded to the advisory committee for the Ramoto and the JPTC. I think it was for that reason, because in terms of the level of involvement with groundwater issues, LIMCOM was not that resourced in terms of groundwater hydrology committee or anything of that same magnitude. So I think this is really a distinction for OCACOM. As we speak now, I think we also should acknowledge that they are busy doing some groundwater related projects for now. both from Angola, Namibia, and Botswana. So these things that we see now, I think they emanate from the efforts that have recently been undertaken in terms of groundwater. The same goes to ZAMCOM. It is not at the same level with Orascom. So I think with that in mind, the region perhaps is coming close to what is desired in terms of setting up structure for groundwater management, information management systems that will actually capture groundwater data, information for effective monitoring going forward. So I thought I should just mention that in terms of the level of distinction between this river basin organization. And Dumisani earlier on said it right, that yes, in terms of the SADC protocol on shared water, it is very shy in terms of explicitly mentioning the issues of groundwater, although it largely talks about water resources at a transboundary level. So, but I must also hasten to say that this development is not actually the first. You will remember that the issue of groundwater that led to the establishment of a SADC-GMI is not really a new thing. It came, but as often as we say, the resources were more on the surface water than on groundwater issues. So I think I'm really happy to see that these issues are now taken on board. In terms of maybe, I don't know if you want me to also conclude by looking at the academic side of it, or you pose a specific question on that. But with regard to RBOs, yes, I think I'll go as far as that and say that, you know, when you have a few neighborhoods, if one neighbor seems to be doing something right, others who are likely to join and do the same thing. So this is really what we think, that in the future, we might see very explicit structures of groundwater governance in the other RBOs. Thank you.
Thank you, Prof. I would want to go to Dumisani as we move towards a closure. But a quick one, Prof. The involvement of academic research institutions from the Greater Phase 1 and the current TBA projects that are being implemented in the region. What would be your quick comment on that involvement, and what will be your desire as Greater goes into Phase 3 and other TBAs are studied? Thank you.
Thank you. I think a quick one would be to say that in terms of involvement of academic institutions, if you listen to what Kuhn presented in terms of the Phase 3 of GGRITA, I think this is really where explicit involvement of academic institutions are coming on board. I know it was indirect because some of the participants for the workshops at different levels, both for groundwater modeling, the water loss and gender issues, they were coming from academic institutions, but not necessarily directly involved in the efforts of these issues. But I think the advent of Phase 3 will cover exactly that, and that will close the gap that was missing in Phase 1 and Phase 2. However, having said that, you also heard him mentioning the course that was undertaken some weeks ago, 2 weeks specifically, looking into groundwater modeling, which was actually spearheaded by an academic institution, and a PhD scholar has been attached to that work. So I think that is really some of the highlights of Phase 1 and Phase 2 moving to Phase 3. And then in conclusion, I know we've got other establishment or structures that are now coming on board in terms of taking to transboundary issues. You've heard of the NEPAD Centers of Excellences, where some of the institutions and the participants that are in this conference are members of. For example, I can see UNZA represented by Dr. Kawawa Banda. and also Thokozani, and also even Kevin from University of Western Cape. I think moving towards that, looking at what are the institutions doing in terms of groundwater issues and corroborating them, and also trying to see how they can be supported in terms of taking the issues of groundwater forward. I think that is really important. In my last statement, I want to acknowledge the efforts of SADC-GMI in coordinating the issues of groundwater in the region, and I think that will go a long way in managing groundwater going forward. Thank you, Brighton.
Thank you, Prof, for that very elaborate, and you have touched on most of the key issues that were remaining to tie the loose ends from what our panelists have discussed so far. I would want to ask a final question to the SADC Secretariat through Dumisani, that looking forward, we have experience from the stars, and we have a very important development that is happening in the region, which is the revision of the Regional Strategic Action Plan 4 to Regional Strategic Action Plan 5, 2021 to 2025. How do you see the experiences from the previous two phases of the stars influencing what is going on into the Regional Strategic Action Plan that is being developed? Dumisani, thank you.
Thank you, Chair. A bit of a tricky question, but to answer it briefly, I wish to highlight it's still under development, the Regional Strategic Action Plan number 5, but clearly there are emerging themes and focus areas which are clear that they are likely to shape it, especially I'm addressing the dimension of groundwater management issues. We're looking at an output area around the transboundary basin and aquifers that are effectively managed as one of the outputs. And another one is on knowledge management and exchange interventions that have to be strengthened. And then the issue that also comes strongly is that of resilience. Resilient communities, resilient water supply systems, and the like around the space of resilience. Ministers of water have recently pronounced themselves explicitly that they want to see in the new strategic action plan the issue of conjunctive management and utilization of transboundary waters addressed. So we have to deal with that. In this respect, we have already started an ongoing dialogue with the SADC-GMI, thanks for their proactiveness in activities that are already aligning with the emerging themes around this support, like building institutions and developing skills, generating and disseminating knowledge, and building resilient livelihoods, which you can tell now that it draws and fits directly to the planned future of the strategic action plan of SADC. Now, to try and come closer to your question, what influences are we receiving from the project? The issue of knowledge management, knowledge development and management, the professor highlighted, Professor Kinabato highlighted in the earlier presentation that there's still further work that needs to be taken up in this space, like understanding a bit more the deeper aquifers issues, the issue of also of continuing joint studies, working together with the research sector and the practitioners, also the the RPOs. One wishes to really say thanks to GMI also for embedding themselves directly in the river basin agencies in the programs that they've implemented in the current phase. Going forward, you can tell the issue of building institutions and developing capacity and skills that will be taken up. So we're looking forward really to that continued active support of the SADC-GMI as well. And then the Prof also highlighted the issue of moving from data collection to decision support. From our end, where we are seated as SADC, will be encouraging the river basin institutions and this project really to deal with that, developing those pieces, advisory pieces that will assist in the decision-making around the issue of transboundary aquifer management, not from the issue of a silo of aquifer versus river basin, but also from that of conjunctive governance of those systems. Lastly, the issue of the replication of the cooperation mechanisms, knowledge, I am seeing it really taking place actively. There are still insights that need to be developed though, as you replicate. For instance, in a river basin organizations with 4 transboundary aquifers, you might see that there's still another dynamics whereby you introduce these institutions for the different aquifers within to be hosted by the one transboundary wide river basin institutions. There is a lot of thinking, but thanks for this project, it's made us wiser and it made us bolder to be a bit more daring towards the issue of addressing the issue, transboundary water management and the governance in the region. That's my submission, Chair. Thank you.
Thank you, Dumisani, for that elaborate response. And dear panelists, I think we are actually slightly above time. It has been a very informative panel discussion that we have had. I don't see any questions in the chat box. I'm not sure who might take this, but if there's somebody who might want to take it, there's a question from Sivashni, which is reading probably a generalized question. If people are familiar with the SDG 6.5.2 questionnaire on TBAs, the transboundary agreements or RASACOM, LIMCOM, USUTU itself do not mention groundwater specifically. It was always part of integrated water resources management. Should these agreements be revised to be more inclusive? I'm not sure who might want to volunteer to take this as we ask James to prepare the closing remarks of this UNESCO SADC-GMI special session. Yes, I see a hand from Nino.
Yeah, just briefly on this one in general terms, because as you might know, in SDGs, the Sustainable Development Goals, and this one is dedicated to transboundary waters, countries are sending reports, and UNESCO is co-custodian agency there in charge of groundwater. And we see that, at least when it comes to transboundary aquifers, that information which is sent, it's not always matching information that we collected from the countries in the course of years. And sometimes it's also that the information is coming from different ministry, etc. Nevertheless, what UNESCO finds very important, and what Jeff is also encouraging very well, is conjunctive transboundary management. That is going to be a topic for coming years, also to be addressed in Greta. So when these results of the SDGs reporting ready sometime of June, July, we'll be able to see for these examples and also examples where the gaps are and where we need to harmonize. Thank you.
Thank you, Nino, for that. I think let me call it a closing response to the questions that we have had in this session. Thank you. Yes, Jonathan, quickly, please.
Just quickly. I mean, look, you know, in terms of to Savashni's question about revising, you know, I don't know offhand the exact text or content of these agreements, but oftentimes we'll use broad encompassing words like water courses, under which you can subsume either surface or groundwater. So does an agreement need to be revised to explicitly mention groundwater? In my mind, that's debatable, and I think you have to weigh the transaction costs of like a protracted process to actually revise that. A better option in my mind might be something like an addendum or a protocol, which can be attached to the existing agreement, which can focus on operationalization of specifics around groundwater. So to think more practically rather than get caught up in legal hurdles. That's a response from my side. Thank you.
Thank you, Jonathan. Prof. Prof.
No, it's not a comment. I was just saying perhaps you did not recognize that we are joined by Dr. Alice Aureli, who may want to greet the audience and maybe say something.
Thank you, Prof. I had noticed the presence of Dr. Alice Aureli, and Dr. Alice, welcome, and thank you for being part of this panel discussion, and also thank you for UNESCO IHP for coming together the SADC-GMI to organize this special session. Colleagues, you might not know Dr. Alice Aureli is the Chief Groundwater Systems at the UNESCO IHP. Dr. Aureli, I'll give you some couple of minutes to say a few words around the topic that we are discussing.
What I can say that listening to all of you, I was really looking at how important is the work that you are doing. And I learned a lot. I think with my colleagues in Harare, with Neno, with the colleague of IGRAC, was a great lessons for us. The way how you are looking at the sustainability of what we have just done make me more excited than before. What I would like to say is that in the legal issues, we shouldn't forget the draft articles on the law of transboundary aquifers. This is really important. There are in the articles important recommendations for governments, and I think that if we are looking at including, for example, in the Orasecom, developing more and more for the stars, then definitely we should look at the articles and see how the articles can be implemented in the field, in the ground. After saying that, I would like to thank everybody for the fantastic work done. We are at your disposal, and our duty is to serve the countries and the purpose of the priority of the country. Thank you so much.
Thank you, Dr. Aureli, for those kind words and words of advice, especially around the draft articles on the transboundary aquifers. And once more to the panelists, it has been a very enlightening discussion that we have had this afternoon. I think we can go on and on and on, but at one point we have to say this is where we stop. It has been such a pleasure. I will not try and summarize. I think all of you, I would go over everything that everybody has said. A lot of wise contributions have come on the table, and we are happy to have your wisdom in the room. Let me, with your permission, colleagues, close this session. and ask James Auramba, the Executive Director of the SADC-GMI, to give us conclusion remarks to this special session and also talk a bit about the way forward. Thank you, and over to you, James.
Okay, thank you, Brighton. Thank you for chairing this session. Let me start by thanking everyone for coming to this session and making it as exciting as it was. When we were planning this one, I must assure you that we were quite anxious what kind of discussions we'd have and where we'll end. But I'm actually feeling quite content with the outcome of this discussion because it has equipped us to move forward with the very wise and fulfilling ideas that came on the table. One of the most important things that we would like to acknowledge is the fact that as SADC-GMI, we have got the mandate that we were given by the SADC Secretariat to carry through all the groundwater programs. And we are proud for the work that we have been assisted by UNESCO IHP through the greater projects in all its phases, including the current phase. So it was not a UNESCO specifically session, but it was a session that is helping us as a region to deliver on our mandate to promote the sustainable conjunctive utilization of our resources in the region and to promote resilience. So thank you very much, UNESCO IHP and the partners behind the scenes for assisting us in this session and to ensure that we capture all those lessons that came from all the very resourceful people that were put together to put these lessons on the table, particularly more so because we've got the aggregator 3 that is in its maturing phase, and more so that we, as SADC-GMI, have got a strategy that we are implementing, particularly through the RSAP5, which looks at all the dimensions that have been raised through this discussion. I took note of a lot of issues that need to be carried forward. So I'd like to assure you, Dr. Aureli, that we'll pick the lessons coming out of here and to ensure that the work that you have done is carried forward sustainably because you have done it on our behalf, and we need to ensure that your efforts don't go to waste. So thank you very much. And thank you once more to everyone who participated in this session and for the organizers that ran around to ensure that we have all these big brains around the table and to get the discussions as smooth as they were. So moving forward, our intention is to capture these lessons learned and to produce them into, we'll also do some policy briefs coming out of this discussion that we'll share with all partners. And we'll also, moving forward, utilize the lessons learned to implement our follow-up programs that we are implementing as SADC-GMI through the RSAP5 and through the other programs that we are seeking support for in the next 5-10 years as a regional center of excellence for groundwater. So that's the outlook of the lessons that we've picked here, which will definitely communicate with you. And of course, we don't intend to implement on our own. We are very few. It's basically myself and Brighton and 3 other guys who are supporting the team. It means we need your partnership. We will leverage on your expertise. We will leverage on anything that you can provide so that we all move together. And of course, we would not be where we are without the support of the SADC Secretariat, here represented by Dr. Kabea, I presume is still here, the SPO, as well as Mr. Dumisani Mzebele, who has been making some very useful contributions to this session. So with these supposed few remarks, I would like to hit the clock at 4 p.m. and close this session and wish everyone a very fruitful evening and look forward to meeting you again tomorrow. Tomorrow we've got some more exciting engagements that would like to partake with you. So with these marks, let me declare this session closed and wish you a good evening. Thank you.